Welcome to the course. So in this course, I'm going to show you one amazing project implementation with the help of MLOps. So here, I'm going to show you how we can build an end-to-end machine learning pipeline with the help of MLflow and DVC. So throughout the entire series, I'm going to implement one amazing problem statement. So the problem statement name is YouTube Sentiment Insights. So those who are running YouTube channel, I think you already know that like checking all the comments is like very hard if you're running a big YouTube channel, right? And it is also hard to understand the subscriber, let's say, sentiment, whether they're giving the positive feedback, whether they're giving the negative feedback, right? Because you don't have that much of time to go through all the comments and you just try to understand all the sentiment. So here I'll be implementing one Chrome plugin, end-to-end Chrome plugin, and we'll try to also integrate the machine learning system with that. So it will try to take the real-time comments from my YouTube, okay, and it will try to analyze whether this comments is a positive or negative. Even I'm also going to visualize some of the amazing graphs so that you can easily understand what kinds of feedback you are getting on your channel. So this is going to be one amazing implementation, guys, because this is a real-time implementation we'll be doing. And those who are running YouTube channel, this would be the amazing project for you guys, okay? So first of all, let's try to understand the problem statement we're going to develop. Then I'm going to show you the entire development and make sure you complete the entire course till the end. And definitely you'll be able to learn each and everything.
Just a quick note. Analytics Vidhya has 100 plus free courses from beginner to advanced on topics like machine learning, generative AI, agents, etc. Complete with certification. Click the I button to explore now.
So let's say this is our YouTube. Okay, so let's say this is our YouTube. Now if I open any kinds of video, so if I open any kinds of video, let's say I will open this particular agentic AI. Okay, this video. Again, you can see the verbose, in this video, memory. If you want to, actually, I have actually different comments. Okay. Now, manually, what we usually do, we just go through the comments and we just try to understand the sentiment, whether this particular comment is positive or it's a negative or it's a neutral one, right? But let's see, we're getting actually thousands comments. Okay, that's at that time actually it's not possible for you to go through all the comments. So if you see my YouTube channel, I have some actually video. It is having actually thousands comments. Okay, so sometimes it is also not possible for me to go through all the actually comments. Okay, so guys, this is my personal YouTube channel. I think you know that I also have the YouTube channel. I also create the content on top of artificial intelligence. So if you're interested, you can subscribe to my channel. So here the solution we're going to propose will be implementing one Chrome plugin. Okay, so I think you know the Chrome plugin, right? So here we also have some Chrome plugin. So if you search for Chrome plugin, okay, so we have different Chrome plugins. So we'll be implementing this particular Chrome plugins. Instead of implementing any kinds of user app or let's say website, we'll be implementing the Chrome plugins. Why? Because whenever I will open any kinds of video, automatically, okay, my Chrome plugin will try to detect this particular video and it will extract all the comments, okay, from this particular video, and it will try to create the dashboard for me. What kinds of dashboard? So let me show you what kinds of functionality actually I'm going to add in this particular project. Let's say this is my, okay, this is my YouTube page. Okay, so let's say I have opened a video. Okay, so here you will have the title, you will have the description like that, and right hand side you also have some, let's say, other content. So once you have opened one video, so what will happen? So let's say you have implemented one Chrome plugins here. So let's say this is your Chrome plugins you have implemented. Okay, so this Chrome plugins will automatically detect this particular video, like which video you have opened. Okay, and it will try to extract all the comments. Okay, it will try to extract all the comments from the comment section. Okay, and it will create a, okay, it will create a summary. So what kinds of summary? Let's say you have 100 comments. Let's say you have 100 comments in a video. Okay, 100 comments. Fine. So what it will do, it will try to create a summary. What kinds of summary? Let's say it will tell you 70%, okay, 70% you have positive comment, okay, and 10% you have negative comment, okay, and 20% you have, let's say, neutral comment, okay, neutral comment. So that's how it will make a summary. Okay, now after opening any kinds of video, you'll be able to understand, okay, how many positive comments, okay, you got in a, let's say, per sentence, how many negative comments and how many neutral comments you got, okay, in a per sentence, because percentage would be like more effective to understand about my sentiment. So if I'm getting more, let's say, positive feedback, that means 70% positive feedback, that means I can understand this video is getting, okay, like more popularity and people are actually really enjoying this particular video. Okay, I hope you got it. So this is the initial, let's say, summary I'll try to generate. Then another feature I will try to add. So the feature would be, let's say, it will create this kinds of box. Let me just draw. It will create this kinds of box, And in the box, actually, again, you will see the same thing. So in the box, again, it will come, let's say 70% of the positive, let's say feedback, then 10% of the negative, and 20% of the neutral one. Okay. Now, if you click, okay, if you click here, so it will redirect to that particular comments. Okay. Let's say if I click here, so what it will do, it will redirect to the positive comments. 70%, like let's say how many positive feedbacks I got in the description, or let's say in the comment section, it will try to like show all the like positive comments. Then I can read like how many positive comments I got, what kinds of comments actually people are doing. Then again, if you click here in the negative comment, it will redirect to the negative comment. If you click here, it will redirect to the neutral comments. Okay, so that's how I will be adding this kinds of feature also. Now if you want, you can also add like so many features. You can also like create different graph. Let's say this is a graph, so in the graph also you can also mention the days wise, let's say time. Let's say today is the, let's say, Friday. So Friday, how many positive feedback you got, how many negative feedback you got, okay, how many, let's say, I mean neutral feedback you got. Based on that, you can also create a graph like that. Then in the next day, let's say Saturday also you can see the same, let's say, distribution. That's how you can also create the graph. So for this you need some, let's say, HTML, CSS and JavaScript knowledge. If you have it, definitely will be able to create this kinds of graphical interface. Okay, and no need to worry, if you don't know, it's completely fine. There would be other team, they will try to create this kinds of functionality for you. So throughout the entire project, actually I actually used ChatGPT a lot to create this kinds of front-end interface. Okay, even I am also not good at this kinds of HTML, CSS and JavaScript. So nowadays you have ChatGPT, you have different websites, so definitely will be able to get this kinds of front-end related code. Okay, you don't need to worry about. And one thing I just forget to tell you, so whenever, let's say, it is opening your video, okay, so in the comment section, it will do another thing. Let's say whatever video is getting, let's say, a positive feedback, it would be in a, let's say, green tick mark. Okay, let's say green icon would be there, so that you can understand it's a positive feedback. Now whenever you have the negative one, it will show you this kinds of red icon. Okay, and whenever you have the neutral one, it will show you this kinds of blue icon. Okay, so this kinds of color, let's say, gradient will also try to add just to understand the sentiment, okay, of the comments. I hope now it is clear. So guys, I think you saw the like solution actually we are going to propose. Now let me tell you about my project plan, like how we'll be developing the entire project, the plan of my project. So first of all, before starting with any kinds of project, guys, you have to plan your project. So we already see the solution. Now with respect to that, we have to plan our project. So see, the first thing you have to do in any kinds of machine learning or deep learning or any kinds of project, you have to get the data. Okay, so you have to do the data collection. So data collection. Now in this case, from where you can get the data, you can get the data from the YouTube. So there are some YouTube API. If you search on Google like how to extract YouTube comments through YouTube API, you'll be able to see some code. Okay, even if you go to the ChatGPT, if you ask, so it will generate the code. With the help of that, you can let's say collect like comments, okay, from the YouTube channel, and you can, let's say, store these kinds of data in a Excel sheet or any other, let's say, file. Okay, but the problem is that actually it will take lots of time, because in YouTube actually we have different kinds of, let's say, category. Let's say we have education related content, we have entertainment related content, okay, and we have, let's say, movies related content. So you have to specify in which, let's say, category you want to work. Let's say if I'm talking about my channel, so my channel is for the educational purpose. Okay, so here I usually upload education and tech related, let's say, content. So most of the comments and, let's say, feedback I get, okay, from the technical related, let's say, feedback I get. So if you want to create this kinds of, let's say, analyzer, that time you have to focus on the education category. Let's say you want to analyze the entertainment channel, that time you have to collect the entertainment actually data. Okay, so it depends upon the category also, but it's not possible as of now to collect all kinds of data from the YouTube. Okay, because it will take some time. That's why we'll be using some predefined data. So here we'll be downloading the data from the internet. I'll tell you where these kinds of data are available, but this is not an exact actually YouTube, let's say, comment data, but it is a similar kinds of YouTube comment data. Okay, so over the internet actually there is a data set called Reddit sentiment analysis data. Okay, I think you know about Reddit website, guys. So in Reddit also you will be getting different technical related actually comments. Okay, technical related feedback, so people are putting right on different topics. So what actually they did, they collected, these are the comments, and they created one data set. Okay, and this data set is available over the internet. So whenever I'll talk about the data collection, that time I'll tell you, okay, how we can get these kinds of data. But whenever you are creating the actual, let's say, YouTube, let's say, sentiment analyzer, make sure you are collecting your own data. Okay, let's say if you are using, let's say, my YouTube channel, just try to collect all of my comments, okay, and try to use that particular data. But just to show you, okay, just to show you, and just to make things actually simpler, I'm going to use the predefined data which is available in the Reddit. Okay, and this is the kinds of similar kinds of, let's say, comments. Okay, whatever comments we usually have in the YouTube, similar kinds of comments we will also see in the Reddit, because this is also a technical related, let's say, website. People are also putting the issues and they're also talking about the technology there. Okay, I hope you got it. Then the second thing will be doing the data pre-processing. Okay, because this would be a text data, so we have to do lots of pre-processing, and we'll be also doing exported data analysis, or we call it as a EDA. This is super important. Whenever you are getting any kinds of data, you have to do, these are the step. Okay, data pre-processing and EDA. So once you have done that, then we'll be creating a basic, we'll be building one basic baseline model. Okay, because as of now we don't have any idea, we'll try to train one basics baseline model, then we'll try to improve this particular baseline model. Okay, so here we'll try to do all the experiment. Okay, we'll try to save all the experiment in the MLflow server. Okay, so next what we'll try to do, we'll try to set up MLflow. Okay, MLflow server on AWS. You can also set this MLflow server on the DAG sub. Okay, but I'm not going to use the DAG sub because DAG sub actually it's a public actually server, everyone can see that. So I'm going to create my private server. Okay, there we'll try to do all the operation. Even in the industry also people are using AWS. Okay, server, and MLflow is a experiment tracking tool. Okay, so once we have set up the MLflow server, then what we'll do, we'll try to do all the experiment one by one. So first of all, we'll try to improve the baseline model. Okay, so here I can write improve baseline model. Okay, so what are the improvement we can do, guys? I think if you have already worked with machine learning, you know that we have different approach we can follow. So let me list down some of them. So let's say if we are using the text data, so that time we can use some technique like bag of word, then TF-IDF technique to do the vectorization. You can also use what to vec. Okay, then I can also do the max feature identification. So we'll do some hyperparameter tuning approach to identify the max features, okay, of our entire token of the data. Then we'll also see the handling imbalance data, because missing value we'll try to handle in the basics of EDA part. Okay, imbalance, if my data is imbalanced or not, we'll try to handle also handling imbalance data. Then we'll try to use multiple model, we'll try to do hyperparameter tuning, okay, with multiple ML model. So here we are not going to rely only one model, we'll try to use actually multiple model, and we'll try to train our data, and I'll try to see the performance of the model, and we'll log everything in the MLflow server, because manually we're not going to do the experiment. MLflow will make our task easy, because it will show you the parallel coordinate plot. I think you know that. With the help of that, we'll try to select the best model out of it. Okay, then after that also, whenever you will get the best parameter of the model, you can also apply some other technique, like you can apply something called stacking model. You can use multiple model, you can stack together and can create a stacking model. Okay, that's how we'll try to figure out our best model out of it. Okay, then once we got the model, we'll try to build. So here I can write, we'll try to build ML pipeline. Okay, using DVC, data version control. I think you know, with help of DVC we can implement ML pipeline. In my MLOps course I already taught you this part. Then we'll also add our model, add model to model registry. Okay, then once our model is added, we'll try to implement Chrome plugin. Okay, Chrome plugin, and that means I told you, no, so I'll create a Chrome plugin, and Chrome plugin will try to do all the operation. Then once Chrome plugin is created, so we'll also try to prepare our CI/CD. Okay, CI/CD, let's say workflow for the deployment. Then we'll also do the dockerization in of our entire source code. We'll try to create the image, and we'll run this project as a container. Then at the end we'll also see the deployment. Okay, deployment of this particular project. And for the deployment, I'm going to use AWS account. Okay, you can also use GCP, Azure, it's up to you. And the entire code management I will try to do on my GitHub. Okay, GitHub, because I told you, if I want to do the code management, version controlling, everything, I have to use the GitHub. Okay, so yes, this is the entire plan, guys, throughout our entire let's say course, throughout the entire program. And guys, I already prepared all the codes and material. Okay, because this is a completely end-to-end implementation, so it's not possible for me to write all the code line by line, okay, in the video. So that's why I already prepared all the notebooks, okay, all the code. So what I will show you, I will use that particular notebook and codes, okay, and I will like explain, okay, whatever things I have done. I will show you all the setups so that you can also do along with me, because I'm expecting so far you have the enough amount of like knowledge, okay, on the Python programming. Because at the end, if you are good at Python programming, everything you can understand. And if you have already worked with machine learning, you can automatically understand the flow, because I'm going to use the machine learning approach only here. Okay, not any kinds of deep learning approach. So yes guys, this is all of our introduction of our project. I hope you got it. So let's connect in the next video, and I will show you how we can collect these kinds of data. Thank you guys. So guys, now we'll try to see how we can get these kinds of data. As I already told you, this data is available over the internet, and we'll be using the Reddit sentiment analysis data, because in the Reddit website we have the similar kinds of comments. So what actually people did, people actually collected these kinds of comments from the Reddit, and they created one actually data sets in the Kaggle, and this data set is available in the Kaggle website. So from here also you can download this particular data, but I'm not going to download from this particular, let's say, Kaggle website. Instead of that, I'm going to get the data from one. I'm using GitHub URL. So see, there is a person, so he has actually uploaded this data in his GitHub, and this is the URL, and this is the CSV data. So it is having two columns. One is the clean comments, that means the comments you have in the YouTube or it's in the Reddit, and one is the category, whether this comment is like positive, negative, or neutral. Okay, so this is what actually we'll try to use. And guys, here actually the category they're using in a numerical representation. Let me show you. So whenever you will see this kinds of one category, that means it's a positive comment. It's a positive comment. Okay, one you will see -1, it's a negative comment. Let's try to remember. Okay, and once you see this 0, that means it's a neutral comment. Okay, so it has three categories: 1, -1, and 0. Okay, 1 means positive, -1 means negative, and 0 means neutral. Fine. So we'll try to use this particular data set for the next video whenever we'll do the data preprocessing and EDA part, and we'll directly load the data with the help of pandas library. Okay, so now let's try to see the next video, which is going to be amazing video. That means here we'll try to do entire preprocessing and EDA part. Hi guys, now we'll try to start our preprocessing and EDA part. So I think you remember guys, we already saw the data. Like this data is available over the Kaggle, and it is also available over this GitHub link. So we'll try to load the data from the GitHub link itself. Okay, so I already prepared one amazing notebook. So the notebook name is Preprocessing and EDA, and all the resources would be shared in your resources section. From there you can download and you can execute with me. So first of all, let me connect my notebook. See, the same thing you can also perform in your local machine. You can use your Jupyter notebook, and there also you can do. But here I'm going to use my Google Colab, because here I don't need to do so many installation, because in Google Colab already all the libraries predefined, pre-installed there. So that's why I'm using Google Colab. See, for the experiment purpose, you can use Google Colab, Jupyter Notebook, anything you can use. Okay, but whenever you will be creating the pipeline, that time you have to use your Visual Code Studio, and everything you have to write in your local machine. Okay, so yes, it is connected. Now let me first of all import some necessary libraries like NumPy and pandas. Now here I'm loading my data. You can see it's a CSV data. That's why I'm using read CSV function, and this is the URL. That means the URL I showed you. So just copy the URL and try to paste here. Okay, now if I execute, it will load the data. So guys, you can see this is the clean comments. That means the comment you have, and this is the category of the comment. So 1 means it's a positive, -1 means it's a negative, 0 means it's a neutral one. Okay, I hope you got it. Now if you want to see how many records you have, you can see the data.shape. So here you have 37,000, 249 actually rows and 2 columns. Okay, now if you want to see any sample, you can call dot sample, and you can see any kinds of comments. I'm calling the clean comment actually column. Okay, and here it is giving me one particular comment. Okay, you can see not even Indian, and this makes even the angry, this historical. Okay, so this is the comments. Fine. Now I will show you data information. That means you can see the data types. So the first column we have the object type, because it's a text category, and the second one it's an integer, because we have the integer category here. Okay, and again you can see we have some missing value also in the data. I'll also discuss this part. So if you want to see the missing value, you can use this particular code is null.sum. It will list down all the missing values. So here you have in the clean comments, okay, you have 100 missing value, but in category you don't have any kinds of missing value. Okay, so there is a possibility whenever you are extracting these kinds of data from the Reddit website or let's say YouTube, so there might be possibility some of the, let's say, comments is not coming. Okay, so that's why this data is missing, because it's a real-time data. Okay, so definitely there would be some problem. Now if you want to see them, you can see where you have the missing. So it is called nan. Okay, nan means it's a missing, but it has the category. Okay, so by default it has some category. All the category is 0. Now if you want to see all the category of the missing value, so here you have 100 actually category which is having missing value. Now as of now, see, I have only 100 missing value. Okay, because I have a 37k, more than 37k is actually example. So removing 100 rows, okay, it's not actually a problem, so you can remove it. But if you have more than 50% data missing, or let's say 30%, 40%, that time you can handle. So as of now I'm going to like drop my missing value, okay, with help of this particular code. Now I'm checking the duplicates. So here I have duplicates, 350 duplicates. Now if you want to see the duplicates, so these are duplicates I have in my data, okay. Now I can also remove the duplicates, okay, I don't need it. Now if I again execute duplicates, you will see that I have 0 duplicates, okay, in my data. Now here I'm checking whether I have any, let's say, new line or not in my, let's say, example, because sometimes actually there would be some actually, let's say, new line, okay, new line in the column, and this will consider as one row, okay, but I don't want this kinds of information because this is not actually meaningful information. So if you want to check, so you can check like that, you can use stripe function and you can okay, check like that. Now here I have this kinds of data, so I have to also remove this kinds of data. So this is the code it will remove. So this line of code will remove this kinds of data, okay, it is done. Now what I have to do, I have to make actually all the character as lower, because I think you know that textual is a sensitive data, so capital F and like smaller f both are different, okay, so that's why we have to bring them in the same actually character, okay, that's why we're converting to the lower. So all the words we are converting to the lower, okay, so lower is important. So let's do, see, now we can see all the, let's say, word I have converted to the lowercase. Then I'm checking if any data is there or not, which is starting with a empty space and which is ending with a empty space, okay. So if we have this kinds of data, we also need to handle, because I don't need the empty space at the very first, okay, of my, let's say, word. Otherwise what will happen, this empty space would be considered as my one token, okay. So if you have basics of like text preprocessing idea, I think you know that, okay, what I'm trying to say. So let me check I have this kinds of data or not. See, here I have this kinds of data, that means it's starting with actually empty, it is also ending with empty, okay, I think you got it. Now if I want to handle, I can use this particular code snippet, so it will replace, okay, wherever actually you have this kinds of like empty space, it will try to delete that particular empty space. Now here I'm checking whether any comment is having any URL or not. So for this you can execute this code. So here I'm using regular expression to find. Now you can see there is no actually URL in my data, so it's completely fine. Now what I'm checking whether any like comment is having /n or not, okay. Inside that you can see I'm checking with the /n. Now if I execute, so see some /n is there, so I have to also remove this at the /n. So how to do it? So this is the code I have written. So wherever you have the /n, it will replace with the empty space. So if I execute, now see there is no /n present in my data. Now these are some basic pre-processing step we have done. Now we'll start with the exported data analysis called EDA. Now we'll try to understand about the data. We'll try to see the distribution and all, right? So now let's try to see the distribution of all of my category. So here if I execute this line of code, so here I'm using matplotlib and Seaborn to do the visualization. So see here I'm plotting all of my categories. So here you can see this is the distribution of your negative category, this is the distribution of your neutral category, and this is the distribution of your positive category. So you can see this data is like imbalanced because negative comments we have less, okay, in the data, and then we have less actually neutral data, then more feedback we have the positive feedback, okay. So maybe there would be an issue whenever we try to build, so we have to also handle this imbalance problem, okay, there. Now if you want to see as a percentage wise, so you can execute this code, it will give you the percentage. So here you have positive feedback 42%, negative neutral feedback 34%, and this negative feedback 22%, okay. I hope you got it. Now I want to make a new column, okay. This column will contain how many words, okay, you have, how many words you have in a let's say comments, okay. So for this you can execute this line of code. Now if I execute, you will see that one column would be created, a word count, okay. Now in a single, let's say, comments, how many words they have used to actually do the comments, so everything is showing here. You can see 9 comment words you have in these comments. Because why I need it, because I want to understand whenever they are writing any kinds of negative comments, or let's say positive comments or neutral comments, how many words they are using to write that. So most of the comments you can see whichever having actually big, let's say big actually, let's say, word count, it is the positive comment, okay. Because whenever we write any positive comments, we also mention the thank you message, okay, and we also appreciate that, so we also explain, okay. That's why we have these kinds of actually big words, and also we have in the neutral word as well, okay. That means if they are giving any kinds of suggestion, okay, they are also telling it's a good, they're also telling something is bad there, so again they're using, okay, more words to write that particular comments. That means these are detailed comments, okay. I hope you got it. Now if you want to see the describe on top of the word counts, so this is the describe. That means you can see the mean, standard deviation, okay, minimum value, 25% percentile, okay, 50% percentile, 75% percentile, everything is visible. Now if you want to visualize this one count, okay, in a distribution plot, so that's how your distribution will look like, okay. You can see, so you can see more distribution, you can see on the 0, that means neutral. So neutral comments actually has more words, okay, words count. in this particular data. Now this is the more advanced plot, so that means it will also show you some color gradient with respect to positive, neutral and negative. So let me show you. This is the plot. Now I think you can see, so this blue represent positive, this one neutral, and this one negative. Okay, so you can see this is the blue distribution, this is the negative distribution, and this is the neutral distribution. So neutral distribution having more. Okay, that means the word count wise. I hope you got it now. Fine. Now if you want to see the box plot of this word count, you can see, I can tell like it also have the outlier problem, because it is like more actually peak point here, you can see. So that's how this box plot looks like. Okay, and I hope you understand, okay, what is box plot in machine learning. Okay, I hope I'm expecting you already know that. Now let's try to plot this box plot for all the category we have. So this is the code. So you can see this is the negative category, this is the neutral category, and this is the positive category. Now here I've also mentioned the comments. Okay, the analysis I got here I've already mentioned. You can also read it out. Then if you want to see the scatter plot, so this is the scatter plot. Here you can see. If you want to see the median counts, so this is the median counts. Okay, median counts. Now I'll do some more pre-processing step. For this I need to install one library called NLTK, Natural Language Toolkit, because whenever you are working with textual data, we need this particular library. Okay, let me install. So first of all, we'll try to see the stop words, and these are the thing. Now see, this particular code will try to identify the stop words, and it will make the count. Okay, how many stop words it has actually in the comments. Okay, so let me execute and let me show you. So if I show you the sample right now it has created another column called number of stop words. Now you can see this particular comment is having 4 stop words. This particular comment is having no stop words. Okay, that's how it will show you number of stop words actually it used. Okay, and we also need to remove the stop words, because whenever we're doing these kinds of sentiment analysis, we don't need to stop words. Okay, I think you already know that. Now you can also plot these stop words in a like a histogram plot, and you will automatically get, you can see. So we have more stop words in the neutral category. Okay, now I can show you the detail actually scatter plot. Let me show you. In this one you can see positive, then negative, and this is the neutral. You can see more stop word is present in the neutral category. Okay, now you can see the median one. This is the median. Now we want to see the top actually most used actually stop words in this particular data. For this I'm going to use this particular code snippet. So here I'm making a counter plot, you can see. So this will count actually top 25. Okay, so here I mentioned 25 most common stop words. So this is the distribution, you can see. So the has been used, okay, most in this particular data. Okay, then and then that, then these. So these are the stop words, and this is the count of the stop words. Okay, I hope you can see this is the count. Then the next thing, guys, I'm actually calculating the number of characters actually used in the comments. So you can see it will create another column called number of characters, and it will get the length of it. Okay, so let me show you. So this is the new column, number of characters, and this is the count of the characters in this particular comments. Okay, because you can also see like how many characters they used to do this kinds of comment in which category, whether it's a positive, negative, or neutral, just to understand the distribution. See, in EDA exploited analysis, you can do actually anything. Okay, so what you feel like, okay, this analysis will help me to understand my data, you can apply. Okay, there is no restriction. So it's not like that you have to follow my EDA technique. Okay, I created one basic EDA technique, but you can also create any other one. But I will suggest whenever you want to do the EDA, try to follow the Kaggle notebook. So Kaggle notebook will give you the broad idea, because there people will try to achieve the higher accuracy. For this, they will be doing different EDA and feature engineering. Okay, so this is the best way to understand the EDA as well as the feature engineering. Okay, so yes, now you can see the describe of the num characters. Okay, this is the count, mean, standard deviation, and so on. Now I want to see how many special character I have. Okay, the character, let's say I have counted how many special character I have and what kinds of special character I have in the comments. Okay, for this I'm going to use this particular code, so it will automatically identify the frequency of a special character and special character. Okay, it is using. So see, these are the special character it is using. So there are some Chinese character also they're using. So if you want to see the entire, see, this is the special character it is using. So we also need to handle this at the special character, because my model won't be able to understand, okay, what is that exactly. Now here we are checking how many punctuation character actually we have in the data. So it is creating another column, and it is checking the number of punctuation. So you know that dot, comma, okay, exclamation mark, okay, these are the punctuation. So let me show you. So see, number of punctuation you have in the character. Okay, which is the distribution. Now you can see the describe. Now one thing I want to perform, I want to see the top actually n-grams. Okay, n-grams actually distribution. I think you know about n-grams. N-grams means actually in n-grams actually I'm using bigrams. Okay, bigrams I'm using 2, 2, 2. That means it will use 2 words to create one particular token. Okay, So if you already learned about like bag of word n-grams, okay, I think you know that what is actually n-grams and what is bigrams exactly, right? So here let's try to create this bigrams and let's try to see the distribution of that. And to apply this n-grams, you have to use counter vectorizer from the sklearn. Okay, I think you already learned this part in your machine learning. And here I'm using bigrams, okay, 2,2. Now this is the distribution, you can see. So this is the bigram. So it is using two actually words together. So free encyclopedia, then encyclopedia team good. Okay, so this is the distribution of the bigram, okay, in my data. So again, it's not actually necessary, but if you feel like, okay, this will help you to understand my data, you can do it. So I was going through some Kaggle notebook. I saw that people are also doing this kinds of, let's say, analysis. That's why I also added here. Okay. Then I can also see the top diagrams. Okay, diagrams, that means 3,3. Okay, 3 word it will take, and it will show you the distribution. So see, 3 word it is taking now. Okay, and this is the distribution of that. Now we are going to remove all the special character. Okay, non-English character. I think you saw some Chinese character was also coming. We'll try to remove them. So this is the code. Now we'll try to use all of my, okay, clean actually, let's say, character, and we'll also try to print the frequency of that. So these are the clean character we have. Okay, and this is the frequency of that. Okay, after removing all the special character. Now this is my data. Okay, that's how your data looks like, and we have created actually so many columns here. Now here I'm going to do the stop word remover. Okay, but here I'm not going to remove all the stop words. I will keep some of the stop words like not, but, however, no, yet. So these are the stop words help us to understand the sentiment of the, let's say, comment. Because let's say if there is a comment, let's say I like this movie and I don't like this movie. Okay, do not like this movie. That time not is helping us to understand that sentiment. Okay, that's why I need some of the stop words. But the rest of the stop words I will try to remove. Okay, now if I show you my data, now you can see stop words count has been changed. Okay, now we'll add the lematizer. Okay, I think you know the lematizer. Lematizer, what it does, it will bring the verb in a root form. Let's say there is a 3 verb, play, plays. So let's say this is the root form of the verb, right? Play. Then we have plays, we have played, and we have playing. Okay, if you see the meaning, okay, so both meaning are same. Okay, all the meanings are same. That means it is representing the play only. So instead of using play, plays, played, okay, these are the tokens. So because at the end I have to reduce the, let's say, dimension, and to reduce the dimension I have to reduce this kinds of complexity. So that's why I can bring the verb in a root form, play. Okay, so this is done by the lematizer. Okay, so here I'm using the word lematizer, and I'm doing this particular lemmatization operation. Okay, whatever comment I have, if they're using multiple verb form, I'm bringing to the, let's say, same root representation of the verb. Okay, now you can see. Now if you want to see the word counts, I think you know what is word count. Word counts will show you like the most frequent word, okay, in a big picture. So let me show you. So this is the word counts. So this thing I used a lot whenever I used to learn the machine learning. So that time actually word count was the main thing to understand that textual data. Okay, I think you remember we used to perform email ham spam classification, right? So there we used to use the word count a lot. Now see, this is the sorry, this is not a word count, it's a word cloud. Okay, you can see this is the word cloud. So this is the cloud, guys. Now you can see here the most used word is the India, then people, okay, thing, one, BJP, Modi. That means, as I can understand, this data is all about the political data, the political comments. Actually we have most of the, okay, comments in that particular data. Okay, so that's how you can get the high level idea about our data, like what category actually we are using, what are the words are used most in the data. Okay, that's how you can understand the sentiment. Now from this analysis I can got to know this data is related to the political data. Now if I want to apply the let's say this particular application, I have to use some political YouTube channel video. Okay, there my model will work better because the category is a political one. But if you're collecting from the education, that time you will see it will be in a education, okay, representation. I hope now you clear, right? Now again I done the same thing. You can see some more word cloud, okay, word cloud representation, and again you can see at the end it's a political data. Okay, you can see Modi, India. Okay, these are the things are coming. Now we'll try to see the most actually occurrent words, okay, in this particular data. So for this I'm going to execute this function. It will try to visualize. Now see, not has been used most in the data, then bird, then people, then India, like, okay, Modi. So these are the most used word in the data. Then we'll see the most actually occurrent words with the category, also category distribution. So here I'm setting a color. If it is a red color, it means it's a negative. It's a gray color, it's a neutral. And if it is a green, that means it's a positive one. So let me show you execution. See, I already executed. So this is the graph I got. So here not, you can see this is the not actually category. So not has been also used in the negative comments. also in the neutral comments, also in the positive comments. And you can see in the positive comments actually not used most. Okay, then BART, then people, then India, like BJP. Okay, so you can see the distribution, interdistribution of the sentiment. So yes guys, this was the pre-processing of and EDA of our data. Now by doing that, I think now you have the sufficient amount of information about your data, like what you need to do exactly with your data, what the problem you have the data. Okay, so I think you got it. And we also perform some feature engineering, okay, task. We handle actually different things, right? We cleaned actually different actually character. We actually pre-process the data. Now what we'll do in the next video, we'll try to create a base model on top of it. Okay, we'll try to create a baseline model with the help of this particular approach. That means whatever things I have done so far, now I'll try to use the same approach. Whatever pre-processing step I have done here, I'll do the same approach there, and I will try a baseline model. Okay, so here I'm not going to repeat this part. So I'll create a function. In this, inside the function, I will do all the pre-processing step. So that's why I showed you this particular notebook separately. That means I want to make you understand whatever pre-processing you need to do, okay, in this particular data. That's it. So yes guys, so this is all about our pre-processing and EDA. In the next video, I'll try to create a baseline model, okay, with the help of this particular technique. So guys, now we'll try to build our baseline model, but before that I have to set up my MLflow server on my AWS cloud, because I already told you all the experiment I'm going to track on my MLflow server, right? So in this video, I will show you how we can set up this MLflow server on our AWS, like EC2 instance. So I already given the instruction, okay, how to do it. So in this notebook, I already shared one link. You can see all required command to install MLflow on EC2. So here I already attached one GitHub link. So here you have all the commands mentioned. Okay, see how to do it. All the commands actually I have written here. So these resources would be shared in your resources section. So from there you can download and you can follow along with me. So let's try to set up this MLflow server on top of our EC2 instance. So make sure guys you have the AWS account. For me, I already have. If you don't have the account, so please try to create one account. You have to add your card, okay, and initially it will deduct actually very less amount of money, at least 2 to 3 rupees, and you will be getting $300 free credits. Okay, so once account is ready, then you will be getting this kinds of window, okay, after login. So here what I need to do, first of all guys, I already mentioned here. So here if you go to this GitHub link, so in the readme file I already mentioned, first of all you have to log into the console. I already logged in. Then you have to create the IAM user with the administrator access. Okay, so let us try to create the IAM user. So I'll go inside my list and make sure you selected your region. So I am inside US East 1, that means North Virginia. So if you are in other region, you can select that one, but I will suggest go with this particular region, okay, US East 1. So here I will search for IAM. And what is IAM? Okay, what is this EC2? Each and everything I explain in my MLOps course. So in this program, I'm not going to explain actually all the services from scratch. Okay, so here we are developing the things. So I'm expecting you are already familiar with these are the concept. So here click on the user. So previously I already created one user. So what I can do, I can delete it, or let's keep it. Okay, I will create a new user. I'll give the username, let's say MLflow server. Okay. I'll click on next. Then you have to add the policy. So click here, attach policies directly. Now here you have to select the administrator access. Okay. Now below you'll see one button. Okay, next. I think you can't see because of me, but just right hand side below you'll see there is a next button. Just try to click here. Then after that you have to create the user. So right hand side again below you will see the create user option. Let's try to create the user. So guys, as you can see, I have created the user. So let's go inside that. Now click on the security credential. And here you will see one option called access keys. Okay, so click on the create access keys, select the command line interface CLI, and I understand the above recommendation. Then click on next. Okay, so here let's create the key right now. So this is my access key and this is my secret access key. Okay, and you need it to authenticate with your accounts. Fine. So I will download as a CSV file because later on I also need that. Got it. Okay, it's completed. Now what I will do guys, now again I will get back. Now it is telling export the credential in your AWS CLI, AWS configure. We'll do it later whenever we'll execute the code. That time we'll try to do. Then I have to create the S3 bucket. Okay, S3 bucket to store my artifact. Okay, that means whatever artifact would be generated, let's say my model. Okay, and I think you saw the MLflow also registered the model, right, with all the configuration and all. So everything will actually track in the S3 bucket. Okay, everything, all the artifact will save in the S3 bucket. So for this we have to create the bucket. So let's create the bucket. I will go to the AWS and here you can search for S3. So this is my S3. Now let's create a bucket. So here give the bucket name. So here I will give MLflow. Okay, MLflow bucket 25. Okay, you have to give a unique name, otherwise it won't be working because S3 is a global service. So you have to take the unique name. then everything just keep it default, no need to change anything. Or you can also remove this option, and I acknowledge, then I will create the bucket. So guys, as you can see, my bucket has also created. Okay, now the next thing what I have to do, I have to create a EC2 machine. Okay, then we have to set up our MLflow server, okay, inside that, and we have to add the port number there. We have to do the port mapping. So how to do it? Let's do it. So I'll get back to my AWS, search for EC2. So here let's launch one instance. I'll click on launch instance, then let's give the name. I will give MLflow server or MLflow machine, anything you can give. So let's select the Ubuntu, and the LTS version I will take this one, 24.04, and instance type, let's take at least 4 GB RAM. So I'll take T2 medium instance. Okay, you can select the key value pair. If you don't have, you can create it. Okay, let's create one. So I'll give, let's say, MLflow, and let's create the pair. So you need this particular PM file whenever you want to access your machine through some third-party tool like Putty and MobileStream, but I'm not going to use them. I'm going to directly open my terminal, okay, in the AWS console itself. I'll tell you, okay, how to do it. But it's a mandatory to select here, otherwise it won't be working. That's why we have created. Now let's allow HTTPS and HTTP traffic from the internet. Now configuration storage here, let's at least take 30 GB. Okay, 30 GB. We can also take less than that, but let's take 30 GB. So once this is done, right hand side below you'll see one option called launch instance. Okay, just try to click here. So yeah, it will launch the instance. Okay, now I'll click on view all instance again beside me. Okay, beside my video you will see the view all instance. Just try to click here. Now see, your machine is running. Okay, now what you can do, go inside the machine and there is a connect button. Okay, just click on the connect and let's connect the machine. So it will open up a black terminal for you, and inside that we have to set up all the configuration one by one. So all the commands I have mentioned here, so we can copy one by one and you can execute. Okay, I'll tell you how to do it. So this is my terminal I got, I think you can see. Now let me install everything one by one. First of all, let's update my machine. I'll copy the first command and let's execute. It's done. Now let's copy the second one. So we are installing Python here, and I'll give the yes permission and press enter. So it's completed. Third commands and let's execute. So I'm installing pip-env. So again, give y to continue. Okay, it is also done. Now I'll copy the next one. I need virtual in env. Okay, then let's create a directory called MLflow. Now I need to go inside that particular directory, and inside that I'm going to install the MLflow with the help of pip-env. Let's install the MLflow. So it's completed. Now I'll install the AWS CLI because I have to access my S3 bucket. Okay, because your MLflow will store all the artifacts in the S3, so it has to communicate with the S3 from the EC2 instance. So to make the connection, I need AWS CLI. There I will add the credential. The credential I have downloaded, AWS secret key and access key. With the help of that, it will configure. Okay, so let's do it. Okay, so it is also done. Now I will install something called Boto3. So let me install Boto3. So Boto3 helps us to actually communicate with the AWS, okay, client. So let's install Boto3 as well. Okay guys, so I installed the Boto3. Now let's activate my shell. So MLflow has been activated, you can see. Okay, let me clear the terminal. So yeah, now I'll do the AWS configure. That means I have to set my access key and secret key. So let's do it. So it is asking for the access key. So where you will get the access key, guys, remember? So we downloaded one CSV file. So this is the CSV file. Let me open in a editor. And make sure guys, you keep this particular secret file safe. If you are sharing with anyone, they will be able to access your machine. So here I'm showing you because after the recording I'll try to delete it. So let's paste. So this is my access key ID. Now I have to give the secret access key ID. So again, this is my secret access key ID. I'll copy, and here let's try to paste. Now it is asking for the region. So I told you I'm inside US East 1, that means North Virginia. Okay, so I have to give the same ID. So let's write, it should be US East -1. You are giving the same name. Okay, otherwise it won't be working. Now it is asking for the output format. I'll keep default, press enter. So my credential has been set. Now finally we can start the MLflow server. Okay, finally we can start the MLflow server. So to start the MLflow server, this is the command you have to execute. Okay, but here you just need to do one modification. So here you have to give the S3 bucket name. I think remember we created the bucket. So let me show you my bucket. I'll go to the S3. So this is my bucket name. Okay, MLflow bucket 25. I'll copy and here I'll try to paste it. Okay, now this is the command you have to execute, guys. Okay, let's copy, and in my machine I'll execute the command. So it should work. Let's see. But one thing, this MLflow runs this port number 5000, okay, but we haven't set the port number 5000, so you have to do the port mapping. How to do it? Go to the security, and here you will see one option called security groups. Then right hand side you can see edit inbound rules, and let's add one rules here. Then I will select custom TCP and port number 5000, okay. Then select the 00, that means you want to access this machine from anywhere. And right hand side, just beside me, you will see one option called save rules, okay. So my 5000 port has been set. Okay, now what I need to do, I need to go inside my instance. So this is my instance, and here you will see one option called public, okay, IPv4, okay. This particular URL, just try to copy, and here you can paste, and just after that you have to give clone 5000, okay. Now if I hit enter, so it should open my machine, but it won't be opening because here it is opening HTTPS, okay. Okay, sorry, it has opened because by default, see, if I copy the URL, one thing I want to tell you, and if I paste in a different window, see, it is HTTP, but if it is coming HTTPS, okay, that time you have to remove the S, okay. Then you have to press enter, then it will open the MLflow server, okay, otherwise it won't be working. So once MLflow server is open, you will be getting this kinds of window, and if you're getting this kinds of window, congratulations, you have successfully installed MLflow in your EC2 instance. Now guys, to test whether my experiment is working or not, what I will do, I'll get back to my notebook, and here let's try to install the MLflow. But before that, let's connect my notebook here. Then in the next video, we'll try to create our baseline model, okay, and we'll try to track all the experiment in the MLflow server. So guys, my notebook has connected. Now let's install MLflow. So pip install MLflow you can do, and it will install MLflow on the Google Colab. The same thing you can do in your local machine also, okay. So here is the test MLflow code. So this will, if it is working, that means if it is tracking this parameter, that means congratulations, your setup actually is done without any kinds of issue. So one thing guys, you have to do here, see, if you want to track your experiment to the MLflow server, so you have to give the URI first of all. So what is the URI? I think remember we copied one URL, na? So here till 5000, okay, just try to copy the entire URL, and you just need to mention it here, okay. This is your URI, that means in this particular server you want to track the experiment, okay, and make sure you are giving your URI, not my URI, otherwise it won't be working. So see, this is my URI, make sure this should be like that. Now with MLflow starts run, and here I'm logging the parameter, let's say parameter I'm logging 15, and MLflow metrics I'm logging, let's say 89%. Let's say this is just a default and demo value I'm just trying to log. Let's try to see whether it's working or not, and I'm not creating any kinds of, let's say, experiment, I'm tracking inside default experiment. Now I'll execute. So here let's execute. So let's see, it should work. See guys, execution is completed and there is no error. Now if I go to the MLflow and if I refresh, okay, refresh the page, so see, this is the experiment it has saved, okay. You can see 8 seconds ago it has tracked my experiment. Now if I go inside that, you will see the parameter I logged. So this is the parameter and this is the metric. That means congratulations, everything is working fine for you. Now we are ready to create our first baseline model, okay, and we can track all the experiment in the MLflow server. Now in the next video, we'll try to create our baseline model. So yes, this is all about from this video, and don't try to stop your server because we have to, okay, keep on running this particular server if I want to track my experiment, okay. So yes guys, this is all about from this video. I hope you liked it. Thank you so much for watching this video, and I will see you. Hi guys, welcome back. So in our previous video, we already set up MLflow server on the AWS. And we saw how we can track the experiment. That means we just ran one code and it was working fine. Now in this video we'll try to create the baseline model, okay, and that means we'll try to create the first model, then we'll try to improve the model performance, okay, one by one. So for this, here is the notebook. It is already mentioned in the resources section. From there you can get it. So first of all, let me import some necessary library, and all the pre-processing EDA step we did, okay, in our, I think you remember, pre-processing EDA session, I'm going to perform the same thing, okay. That's why I for you, okay. So let's load the data. So these are common, I think you remember. Then we are dropping the NaN value, dropping the duplicates, okay. Then we are removing the space, okay. Then we're importing an LTK or handling the stopwords and all, right. And this is the pre-processing function I have written. So it will do all the pre-processing step we did, okay, in our that particular session. So here I kept only one function, but there I was running this particular code, okay, cell by cell. That's why. So now let's apply the pre-processing on top of my entire data. That is clean comments in my like input. So entire data it's completed. Now if I show you my data, so this is my data. So now we'll try to base model. So here MLflow, then MLflow sklearn, and because you know that this is a machine learning project and we'll be using sklearn library, so that's why MLflow sklearn to track my experiment. Then the first model we're going to train called random forest classifier, because this is a classification problem statement and I'm going to use counter vectorizer. Then test split, then you can see I'm importing some more matrices and like some required packages. Now let me import them. Now first of all we have to vectorize the data because it's textual data, we have to convert it to the number. For this I'm using counter vectorizer, and max features as of now I'm taking 10,000. okay, so this is called bag of what I think you know. So let's create the vectorizer. Now let's transform on top of my x, and this is my y. okay, so after converting to the number, this is the number I got and this is the shape. okay, because the 10,000 words I taken, okay, that's why 10,000 dimension, and this is my y, that means my level data. okay, now this is the y shape also. That means after removing all the missing value and all, you have 36k, more than 36k actually records. Now to set the experiment on my MLflow, first of all I have to set the URI. So I think remember we collected one URI address here, so let's copy. So this URI address guys, okay, I think remember. So now let me add it here. So let's set, and here I'm going to create an experiment. okay, experiment name. See what happens if I go to the MLflow, if I refresh, it will create a separate experiment here. See RF baseline. okay, so inside this particular experiment all the log would be saved. okay, I'm not going to, so I created the new one. Now let me install Boto 3 just to configure with my AWS, because here it will also actually store the artifacts to the S3 bucket. For this I also need to set my AWS secret key and access key ID in the Google Colab. So for this I need to install AWS CLI. Let me install. So it's completed. Now let me add the secret key and access key. For this, run this command AWS configure. So it is asking for the access key ID. I'll copy, and here's key ID. Now press enter, then access secret access key ID I'll copy and I'll paste it here, and so it should be US East 1. okay, now press enter. Output format, press enter. So it is set. Now here I'm doing the test split. okay, then after that I'm logging the flow server, I'm logging tags. These are some tags. Then I'm also adding the description, okay, of my experiment, and here I'm logging the parameter. So the first parameter I'm logging the vectorizer. So here I'm logging the types of vectorizer I'm using, which is called counter vectorizer, and the max features actually I'm using. okay, that means 10,000 max features. Then for the random forest I'm setting some parameter. I think you know random forest as having different parameter. Random forest classifier. okay, so it has different parameter like n estimator, okay, as citation, max depth. So these are the parameter you can also set. So I'm setting n estimator and max depth. okay, so this is the parameter I have taken, and it's completely hyperparameter tuning, so that is why actually we're doing. okay, now here I'm logging the parameter. After that I'm training the random forest model, then I'm calculating the and logging the metrics on the MLflow, and I'm also calculating the classification report. That means from here I'm getting actually metrics, okay, some metric classification metrics like precision, recall, and F1 score, and I'm also getting the confusion metrics. okay, then I'm plotting it map, then I'm saving the plot in the MLflow artifact. okay, that means it will save in the S3 bucket, and I'm also logging the model. That means it will also save the random forest model, the model actually it has trained. Then I'm also saving my data. okay, so yeah, so now let me execute and let me show you, okay, what will happen. So the simple machine learning is split, then vectorizer, train the model, but I have written inside a file. So guys, as you can see, my execution is done, and this is the confusion metrics actually I'm getting. And if I want to show you the classification report, so this is the classification report. Here I got precision, recall, and F4 score. okay, but as you can see, this precision is very high for the negative class. okay, but for positive, neutral, and negative it is a little bit low. okay, why? Because of that I think imbalance problem. So I'll also show you how we can improve the quality of the model, because this is just a fast experiment we did. okay, now one thing I want to do, the pre-processed data. okay, the data we have done the pre-processing, I think remember the entire function we applied. So every time I don't need to execute this function. okay, every time I don't need to execute the function, what I can do, I can save the pre-processed data, and going forward whatever experiment I'll try to do, I'll try to load the pre-processing data. okay, instead of loading my like raw data, the data actually I have. So let's save the data as a CSV. So I think here it has saved. Now what you can do, you can download. okay, so for it you can download. okay, yeah, and if you want to load it, so with the help of pandas you can load it. Now let's go to the MLflow, and if I refresh, see, this is the experiment it has saved. Now if I open it up, so here is the parameter, all the parameter you have saved, and all the matrices you can see here. okay, successfully able to log the information in the MLflow. And here the precision and let me see the accuracy score I got here. So this is the accuracy, 64% accuracy I got. But this 64 is not a good accuracy. Still, I need to accuracy of the model. So guys, you saw all the experiment has been saved in my MLflow server. That is all the parameter you set, even all the matrices as well. Okay, and we can see with the help of random forest classifier and with the help of default parameter. That means these are the default parameter I got here. I got actually 64% of accuracy. Okay, and all the, let's say, metrics has been, say, artifact has been also saved. For this, just go to the bucket. Okay, the bucket you have created, and just try to refresh here. Okay, now you'll see that the experiment ID. Now if I go inside that, so this is the artifact, and inside that it has saved the confusion matrix you have saved as the data set as well as the your model. Okay, this is the model. So that means everything is working fine so far. And this is our first experiment, and with the help of that we can't decide this model is good or not, because still we have getting some more technique. What are the technique we can apply? But this is just an initial model we have developed. Okay, and here one thing I just forget to tell you. If I go to the overview, so here is the run ID. Okay, now if I go to the S3 bucket, so this is what your let me show you. This is the experiment ID. Okay, that means the first one is the experiment ID, and inside that you have the run ID. Okay, this is the run ID. Okay, so that you won't be having any kinds of confusion, because if you run multiple time, it will create multiple run ID and multiple experiment ID. So yes guys, this was our first experiment we did. We just baseline model. Now in the next video we'll try to see how we can improve the performance of the model. So guys, in our last video we saw how we can train one baseline model, and to train the baseline model I used random forest classifier, and I used counter vectorizer with some default parameter, and max feature is equal to I have taken 10,000. Okay, now I told you, and we saw that like we accuracy score we got 64% of accuracy, right? And I told you we can still like improve the performance of the model. For this we'll be doing a second experiment. So here we'll try to select which vectorization. Okay, that means instead of using this counter vectorizer with a default parameter, which vectorization I can use. I think you remember guys, we have different vectorizer technique. Like we have bag of word, we call it as a bow. Okay, then we have something called TF-IDF. TF-IDF. Okay, so in bag of word you have something called n-grams. Okay, then you have like bigrams. So n-grams, if you give the n parameter is equal to 2, it should be bigrams. Okay, bigrams. Then we have trigrams. If you give n is equal to 3, it will be trigrams. Okay, I think you know what is bigram, trigrams, right? And this is what actually TF-IDF. And we have another one called word2vec. So I'm not going to apply the word2vec. I'm going to apply these two vectorization, and I will try to select which one is the best. Okay, which one is giving more good accuracy. And whenever we'll be using bag of word, we'll also try to test whether I have to use the bigram or it's a trigram. Bigram means 2 words. Okay, it would be 2, 2. Trigram would be 3, 3 words. Okay, and if you give 4, 4, it would be 4 grams. Okay, that's how. So let's try to do the experiment, and let's try to figure out which vectorization technique I can use to improve my model performance. So for this, I'm going to use this particular experiment to notebook, and it would be available in your resources section. So again, let's try to install your AWS, then this MLflow and all. So let me install everything. Okay, so this is installed. Now let's try to configure my secret credential. Now I'll copy my access key, then secret access key, then region, yes, east1, and output format, just keep it as default. Now I have to set the MLflow URI. So from my first experiment, I'll copy the URI. This is the URI, I'll copy, and here let me just paste it. Now instead of saving my experiment in my RF baseline, that means in my first experiment, I am creating another experiment called experiment 2, bag of what versus TF-IDF. Okay, let me create the experiment. Okay, MLflow is not defined because I have to set the URI first of all. Create the experiment. Okay, now if I come here and if I refresh, see, it will create another experiment. Okay, experiment 2, bag of what versus TF-IDF. And inside that you will save all the experiment. Now let's run. So here I'm importing my counter vectorizer as well as the bag TF-IDF. Okay, that means bag of what. Counter vectorizer is nothing but your bag of what if you're setting the parameter, and this is your TF-IDF. And again, I'm using random first and everything by default. Okay, whatever things I used in my previous experiment. Now instead of loading my raw data, I'm going to load my preprocessing data. I think you remember we saved our data as a preprocessing. Okay, .csv. So let's upload here. I'll upload. So here is the data, preprocessing data. I'll try to upload here. See, it is uploading. Done. Now I can load the data. Now see, I loaded the data successfully. Now here I have created one function called run experiment. Inside that, here I'm taking, first of all, user can pass the vectorization type. So here if user is giving vectorizer is equal to bag of word, then it will run the bag of word. Okay, with the n-grams actually size. I'll tell you the n-gram size, and otherwise it will run the TF-IDF vectorizer. Okay, and it will take the vectorizer max features and vectorizer name. Then I'm doing the 10 test split. Okay, then I'm doing the vectorization, and here I'm doing the same thing, setting the MLflow, let's say tags, then log in the parameter. Then this is my random forest actually parameter. Okay, log the parameter, training the model, predicting the model, calculating the accuracy, getting the classification report, and I'm getting the confusion metrics and all the, let's say, classification metrics, and I'm storing in the artifact. Okay, now here is the n-gram range. Okay, now you can see guys, I'm trying with actually 1 gram. Okay, then I'm trying with actually a bigram, then I'm trying with trigram. Okay, this is called unigram, this is called bigram, this is called trigram. Okay, 3 experiment I will try to do, and I will try to see what is the best one. And max feature I'm taking 500. Okay, previously I have taken, I think, remember, 10,000, but here now I'm taking 5,000. Okay, now here the first experiment I'm running on top of the bag of word, and the second experiment I'm running on top of the TF-IDF. Now let's try to see which one is working better. So I'll execute the code. So after the execution, it will save all the logs in the MLflow, and from there we'll try to select the best model out of it. So let's wait, it will take some time. I will pause the video, and once it is complete, I'll come back. So guys, as you can see, my execution is completed. Now if I go to the MLflow and if I refresh, that means in my experiment 2, if I refresh, there are 6 actually runs. Okay, why 6 runs? Because if you see, I did actually 6 experiment. So first of all, I did bag of word, and for bag of word I did this 3 experiment with unigrams, bigrams, and trigrams. That's why 3 experiment for the bag of words. Okay, and again for the TF-IDF I did the same thing, that means 3 experiment, unigram, bigrams, and trigrams. Okay, that's why another 3, that means 6 experiment I got. Now let's try to compare all of them. I'll try to select all the, let's say, experiment, and I'll click on the compare button. So here you can see guys, I'm getting the parallel coordinate plot. So first of all, I'll select the accuracy. So let's try to see the accuracy. See, so the highest accuracy I'm getting 65 with this model actually. Bag of what with this one, trigram. Okay, bag of what with trigram, I'm getting 65% accuracy. And remember, in my experiment 1, I was getting 64% accuracy. Okay, with the default setting. But after applying this particular experiment, I can see accuracy has improved slightly. And with this particular setting, trigram with bag of what. But I also need to see my precision and recall, because I told you for the negative class precision was high because it was imbalanced data set. Okay, so I also need to see the precision and recall. Based on that, I'll try to decide which one I have to select. So again, I will click here. So let's see, select the minor, that is negative class precision. Now here you can see the negative class precision, I'm getting the highest accuracy here with this model. Bag of word, this one, bigram. Okay, bag of word bigram, I'm getting the highest precision. But I also need to see the recall. So let's select the -1 recall. Okay, now for the recall, you can see it has been changed. So the highest accuracy I'm getting, so you can see I'm getting the highest recall with this model. So TF-IDF with the trigram settings. Okay, TF-IDF with the trigram settings, guys. Okay, so this particular like settings we'll try to use. Okay, and here I'm getting the, you can see, higher recall, because I don't need to rely on the precision, because precision is high for the negative class because it was the imbalance problem. Okay, so I also need to take care about the recall. So if you have if you have idea about the recall precision, I think you know, okay, what I'm trying to say. So this is the concept of machine learning. By seeing this particular matrix, you have to decide, okay, which model you have to select. So guys, from this experiment we got to know we have to use this setting, trigrams with TF-IDF vectorization. Okay, so we found our like best actually parameter. That means from this particular experiment you can give the conclusion, I have to use trigram setting, okay, with the help of TF-IDF vectorizer. Now guys, in the next experiment we'll try to figure out the best max features. Okay, what would be the max features for the best model out of it. So this thing we'll try to do in the experiment 3. So now let's try to see the experiment 3, how it can be done. So guys, in our last experiment we got to know about our best vectorization technique with some best parameter like trigram settings, right? So here we got TF-IDF with trigram settings. Now in this experiment we'll try to figure out how many max features you have to take there. Okay, so for this we are going to do another experiment, and that experiment name would be experiment 3. So again, let's connect my notebook and let me install all the necessary library you need. Okay, see, these are steps are common, okay, for all the experiments. So I'm not going to explain from scratch. So let me set up quickly. So guys, as you can see, my installation is completed. Now let's try to configure. So again, I'll copy the access key, then my secret access key, and my region. So US list, sorry, should be -1, and output format should be default. And all the, let's say, bucket, okay, all the experiment has been saved to the S3 bucket. Okay, so this was my second experiment. I think this was okay. This was the second experiment. Inside that you have the runs ID. 1 2 3 4 5 6 runs I did because 6 experiment it did. Okay, I think remember. So yeah, every time all the artifact would be saved in this 3 bucket. Now I'll get back. Now let's try to set the URIs. I'll copy the URI from my previous notebook. This is the URI. I'll copy, and here let's try to set the URI. Set. Then I'm creating another experiment called experiment 3, TF-IDF diagrams max features. Okay, now it will create another experiment here. Let me show you. See, experiment 3. Now inside that it will save all the experiment. Now again I'm importing all the necessary library, and I have to load my pre-processing data. Let me upload. So it's done. Now let me load, and here is the function I created, guys. So here I'm using diagram with TF-IDF vectorizer. You can see I'm using TF-IDF vectorizer because from my previous experiment I got to know. Okay, now here you can see I'm performing the vectorization, setting all the tags in the MLflow. Then you can see setting the random forest parameter, training the model, doing the prediction, getting the accuracy, and getting the classification metrics. And I'm actually getting the, and here I'm plotting the confusion metrics as well as the login this metrics to the MLflow. Okay, and as well as I'm also doing the model login. And now here is the max features, guys. Okay, so here I've taken 1 2 3 4 5 6 7 8 9 10 max features, and I have written one for loop. So every time it will take actually one max features, and it will try to do the experiment, and then I will compare the model and try to select the best max features, okay, out of it. So let's try to run the experiment. Okay, that means it will run actually 10 runs. Okay, 10 runs it will do. Let me show you. So again it will take some time, so I will pause the video. Once this execution is complete, I will come back. So guys, as you can see, my execution is done. Now if I go to the MLflow and if I refresh here, you will see I will have 10 runs here because I used 10 parameters. I think remember all the 10 runs, okay, with all the max features. Now let's try to compare. I'll select all of them and I'll click on the compare, and it will give me the parallel coordinate plots. Okay, now from here I'll select the accuracy. First of all we'll see the accuracy, then we'll also see the precision and recall. Based on that we'll try to select. So my maximum features here, you got you can see the maximum features. Okay, so you can see thousands to 10,000s, and here is the accuracy. Now one thing you can observe, accuracy is increasing whenever I'm taking, okay, a minimum max features. That means if I'm taking, let's say, thousands or 2,000s, okay, that time my accuracy is increasing. But we can't rely on the accuracy. We also need to see the precision and recall for the negative class, because we saw that negative class was like high. That means there was an imbalance problem in the negative class. So again, what I will do, I'll select the precision of the negative class. Okay, now after you can see this precision is high whenever your max feature is high. Okay, now this graph has been changed. Precision is high whenever max feature is high, but I can't rely on the precision. I also need to see the recall. So now let's see the recall also. So minus plus recall. Now again you can see there is another change in the graph. Now your recall is high whenever you are taking this max feature is equal to low. That means 1000. Okay, so that means this is the best actually settings we can take right now. We don't need to rely on the precision only, we also need to see the recall. Now if recall is like, let's say, good, now we can select this particular best settings. Okay, that means thousands features we can take. That means low features with a higher recall. Okay, higher recall or higher accuracy. Got it? Now see, from 3 experiments what we got to know. The first experiment we saw like we can use actually this one, TF-IDF. Okay, TF-IDF with diagram. Okay, diagram. Then we got to know the max feature we can use 1000. Okay, so this is the conclusion we got. Okay, this is the conclusion we got. But again, still we need to improve the model performance. We saw that we have the imbalance problem in the data. So next we'll see like how we can handle the imbalance problem with different features. So now let's try to do another experiment in the next video. Okay, there I will show you how we can handle the imbalance problem, and we'll try to use the same settings there. So guys, we saw actually different experiment. Now in this experiment we'll try to handle the imbalance data. For this we'll be using different techniques. So I think you know in machine learning we have different techniques we can follow to do the imbalance handling, right? So this is experiment 4, and let me first of all install all the library, and I'm going to use my previous setting. Okay, so far whatever settings we got, okay, TF-IDF with diagrams, okay, with actually max features, okay, that thing we'll try to use. Then we have to configure the AWS. So let's copy access key, then I'll copy secret access key, then US is 1, then I'll keep it as default. Now I have to set the URI. So let's copy the URI from my previous notebook. I'll try to set. Now let's set the URI. Now here I'm naming this experiment as experiment 4, handling imbalance data. Now if I go to the MLflow, if I refresh, you'll see that experiment 4 has been created. Okay, Inside that, we'll try to save the experiment. Now let's import all the necessary libraries. So guys, I think you already know in machine learning we have different techniques we can follow to perform the handling imbalance, like smart, Addison. Okay, so these are the things are there. Then undersampling. So let me show you. I'll be applying 5 techniques here. So these are the 5 techniques, like class weights, oversampling, Addison, undersampling, and smart ENN. Okay, so these are the 5 technique we'll try to apply. So it's loaded. Now let's load. Okay. Now this is the function I have written. So here I selected ngrams max features, and here I'm using TF-IDF vectorizer, and I'm doing the test speed. Then here I've written some condition. If imbalance method is equal to class weight, then it will apply the class weight. If it is oversampling, it will apply the oversampling. Okay, and in oversampling we can use something called smart. Okay, smart. With the help of smart we can perform the oversampling. Then if it is Addison, I'm using Addison. If it is undersampling, I'm using random undersampling. If it is smart ENN, I'm using smart ENN. Okay. So smart ENN and smart is a different thing. Okay, don't be confused. Now here I'm again logging all the MLflow log. Then this is my model, random forest model, predicting, then classification report. Okay, and here I'm storing in the artifact as well as I'm saving as a PNG file, and I'm logging the model. Then here are the imbalance methods. So class weight, oversampling, Addison, and undersampling, smart ENN. So here I've written a for loop. So this will look through this particular list and it will take one by one. That means 1, 2, 3, 4, 5. Okay, 5 times your experiment will run. Okay, 5 run it will try to create. So let's try to see which one will work better. So again, it will take some time. So I'll pause the video. Once this execution is complete, I'll come back. So guys, my execution is completed. Now if I get back and if I go to my experiment 4, so here I have all the experiment. That means all the 5 experiment I have. Now let's try to compare. So here I will select the accuracy first of all. So you can see the accuracy, the highest accuracy I'm getting whenever you are using undersampling. Okay, so whenever you are using undersampling, you are using highest accuracy, but I don't need to rely on the accuracy. I will also, okay, sorry, I think I selected the precision as well. Now see the accuracy. So the highest accuracy you are getting whenever you are using undersampling. Okay, now let's try to see the precision. That means -1 negative class precision. Now precision you are getting whenever you are using undersampling here. Okay, see undersampling you are getting the highest precision. Now let's try to see the recall as well. So for recall, whenever you are using smart ENN, that means you are using highest recall. But one thing actually I observed later on, if I am, let's say, selecting my positive precision, okay, precision for the positive class, so this will change. Okay, see, this is the precision for the positive class and recall for the positive class. Let me also select recall for the positive class. So if you select all of them, so here you can see my oversampling techniques is working better. Okay, for all the, let's say, experiment. Okay, so I already compared with different actually, let's say, metrics, and I saw that oversampling is working better than any other actually, let's say, technique. Okay, so let's try to use the oversampling instead of using smart NN, or let's undersampling approach. Okay, so I'll try to use the oversampling to perform my imbalance handling. Okay, we'll try to handle the imbalance with the help of oversampling approach, and inside oversampling we use something called smart. Okay, now we got actually all of our settings. Now from the next experiment onward, we'll try to train the machine learning model. That means we are not only going to train the model with the help of random forest, we'll also train the model with different classification models. Okay, all kinds of classification model you can train, but I'm not going to show all of them. You can try. I've shared you the notebook. Okay, so only just need to change the model and you have to train the model with the help of these are the settings. Okay, that means you can use TF-IDF with diagram, thousands actually max features, and you can use this one, imbalance handling, oversampling. Okay, oversampling, smart. Okay, so these are the setting you can use to train any kinds of model. So next video onward, we'll try to train some machine learning model. Okay, then we'll try to figure out the best model out of it. So guys, so far we have done different experiment and we got some conclusions. So let me discuss. So first thing, we trained one baseline model with the default, let's say, settings, like we use counter vectorizer with 10,000 actually max features. Okay, and we achieved 64% accuracy. Then in the second experiment, we identified the best vectorization actually model, which is nothing but TF-IDF. Okay, TF-IDF with diagram features. Okay, diagram features. Then in the third experiment, we got to know we have to use max feature. Okay, max feature is equal to 1000, because the less you are taking, the more good performance you are getting. Then we did the imbalance handling and we got to know we have to perform something called oversampling. Okay, oversampling. For this we are going to use smart. Okay, so these are the let's say setting we got after doing all the experiment. Now what we'll do, we'll try to train different kinds of machine learning model. Now you can train like random forest, we already trained. Now you can train XGBoost. Okay, you can train, let's say, decision trees. Okay, you can also train naive bias. So all kinds of whatever, let's say, classification machine learning model you have, you can train all the model with these are the parameter. Okay, I will show you a couple of them. I'm not going to show all of them because I think you got it, okay, how to do it. But whenever you are doing, you have to apply on top of all the model, then you can select the best model out of it. Okay, so I already did the experiment previously and I find my best model out of it. And so guys, for me, after applying actually all the model, light GBM, okay, so there is a model called light GBM. Okay, so this particular model is working better for me. It is giving me the higher accuracy. Okay, after applying actually all the experiments. So let me show you the experiment notebook I did. So first of all, I tried with XGBoost. So for this, I need to install actually XGBoost and all the required library. Then after that, just configure, just to log your experiment in the MLflow. Then try to set the URI, then create the experiment name, then just try to import all the necessary library and see. I'm not actually only training the XGBoost model, even I'm also doing the hyperparameter tuning of the XGBoost model, okay, with a different parameter. I think you know how to perform hyperparameter tuning with the help of Optuna, or let's say there is another one called Grid Search CV, okay, you can use it. But Optuna will work better, it will, because it's a powerful package, okay, with the help of that you can do the hyperparameter tuning. And you can see I'm importing actually XGBoost classifier and all. Apart from that, I was also importing some other model, but actually I removed. Okay, what I did actually, I created separate notebook for separate model, because in one notebook it will be taking lots of time. Okay, because it will do the hyperparameter tuning on top of all the models. It will take time. That's why I created a separate notebook for that. So here I'm loading my data. Then first of all, if you're using XGBoost, you have to like change this minus category, because XGBoost doesn't support the minus, okay, minus category. So this minus actually I'm defining as a 2. Okay, so 0 is 0, that means 0 is the neutral, 1 is the positive, and 2 means it's a negative. Okay, that means minus 1 I'm considering as a 2. Okay, then dropping the actually none value. Then here is the diagrams, then 1000 max features, and I'm using TF-IDF vectorizer. Then I'm applying this mod, that means oversampling. Then I'm logging the information over the MLflow, okay, training the model. And this is the XGBoost, okay, I'm training. And with the help of Optuna, I'm doing the hyperparameter tuning, okay, and this is the result actually I got. And I did the hyperparameter tuning with the help of Optuna. Okay, and again this execution will take time, because it will take actually different parameter. It will train the XGBoost model, XGBoost having actually lots of parameter. Okay, then after that I did some more experiment with like decision trees, then k-nearest neighbor, then naive bias. Okay, then at the last I did another experiment with the help of light GBM. Okay, light GBM. So this is the model, this is another classification model in machine learning. Again I did the same thing, okay, with all the default parameter. You can see I did the same thing. And here with the help of this optional library, I did the detailed hyperparameter tuning. You can see these are the parameter actually I'm using. Okay, so I did the entire hyperparameter tuning here, light GBM classifier. Then I'm logging the model in the MLflow, and this is the Optuna code. Okay, so that's how you can run the hyperparameter tuning. And after that, here is the results I got. Okay, so these are the best parameter I got. Okay, these are the best parameter I got for this light GBM model. Okay, and this model is giving me good accuracy score. Okay, so after using all the model, all the classification model, this light GBM is working fine for me. So again, you can try, guys. I already shared the notebook with you. Only you just need to change the model. Okay, the code will remain same. Okay, I hope you got it. So guys, the final conclusion I got, we have to use this model actually, light GBM model. Okay, with these are the final parameter. And another way you can improve the model performance, we can use something called stacking. Okay, what is the stacking? I will discuss in the next class. Okay, with the help of stacking also we can increase the performance of the model. So with that, guys, thank you so much. Let's see the stacking experiment, okay, in the next video. Hi guys, so as of now we found out our best model, which is nothing but light GBM, and I found some parameter. So whenever we'll try to create our final model, that time I'll tell you, okay, what are the parameter I got. And I told you we can still improve the performance of the model. So that's why I applied actually stacking technique. Stacking means you are using multiple model. Okay, you are combining them together and you are creating one stacking actually model. So again, I imported all the necessary library. So for stacking, actually I'm using stacking classifier, and I'm using actually some model, like I'm using logistic regression, nearest neighbor, and light GBM. Okay, these are the 3 model I'm using. So loading my data, then I'm doing some pre-processing step, 10 test split, then I'm doing the TF-IDF vectorizer. Then here is the live GBM model. Okay, then I also prepared the logistic, and this one k-nearest neighbor. Okay, then this is my stacking model. And after actually doing the training, so here is the metrics I got. Okay, So by seeing the metrics, guys, I decided I will be using LightGBM model only, not the stacking approach, because the performance actually is same. Okay, the LightGBM performance and the stacking performance are actually almost same. So that's why I'll be using LightGBM just to make my model simple, because here you are using a stacking model, so multi-model you are connecting each other, so it's a little bit complex architecture, right? So that's why I'm going to use the simple architecture, which is nothing but LightGBM with best parameter, which we did in our experiment 6. Okay, so here actually I think you remember we did the training of the LightGBM with a detailed parameter. Okay, hyperparameter tuning with the help of optional. So yes, so this is the stacking one. Now from the next video onward, we'll start building the ML pipeline. Okay, and whenever we'll train the model, we'll try to use our best parameter, the parameter we have selected so far. Okay, from all the experiment, and our final model would be LightGBM model. Okay, and you feel free to explore any kinds of model. Okay, I already told you got the flow how to do it, so please try to experiment on any other model, naive Bayes, okay, or let's say any kinds of model you can use, and try to actually do your own experiment. Okay, and you can let me know. So guys, as of now we have seen different experiment and we figured out our best model settings. Now from this video onward, we'll be building our ML pipeline with the help of DVC. So in this video, first of all, let me tell you what are the component we're going to develop inside our ML pipeline. I think you already know in ML pipeline, we implement different component, right? So here, let me write ML pipeline will be building pipeline. And for this, we'll be using DVC, okay, for the pipeline tracking. So here, the first component we're going to develop called data ingestion. So in this component, we'll be ingesting the data from the URL itself. Let me see whatever code as of now we have written in our Jupyter notebook. Now, so the same code we'll be writing as our modular coding inside .py file. Okay, and some slightly modification I'll be doing there. I'll let you know. I already prepared like all the component. I will give you the entire walkthrough. Okay, how I have prepared, so you'll be able to understand. Then the next component will be developing called data pre-processing. Okay, pre-processing. Okay, because I think you know this data we have to pre-process after ingesting. Then the third component will be developing model building, because so far we have done so many experiment and we figured out our best settings, right? Model settings like so I already showed you from the first experiment. Actually, I figured out our best vectorizer. Then we figured out the max features. Then we figured out the like imbalanced data handling technique. So different like settings we already got, right? So with the help of that, we'll be training our model. So here I'll just write model building. So once model building is done, then we'll be implementing model evaluation, and all the evaluation metrics is okay. All the, let's say, experiment we'll try to again track in the MLflow. So here let me write with MLflow, because I want like whenever I will execute my pipeline, so every time it will actually save all the artifact inside my MLflow. Okay, all the experiment in my MLflow, so that I can track later on, right? Then fifth, I'll be doing the model registration. So here model registration will be doing model register. Okay, so we'll do the model register in MLflow, and later on from this particular register hub, we'll try to take the model and we'll create an API with the help of a Flask, and we'll try to use the model. Okay, that means we're going to develop our Chrome plugin, right? So how it will communicate with the model through the API, right? I think you know we can create the API with the help of Flask. So we'll try to do the same thing here. So yes guys, these are the component we'll try to implement one by one, and if we integrate all of them together, it will become our ML pipeline. And to track the entire pipeline, we'll be using one amazing MLOps tool called DVC, okay, data version control. So let's try to start the implementation. First of all, let's try to see the data ingestion part, okay, how it can be done. So I already prepared like all the, let's say, component code. So first of all, let me create one GitHub repository. So here I will create a new repository. Let's give the repository name as, so I'll give the name YouTube Sentiment Insights. Okay, YouTube Sentiment Insights. So this is the name. You can give any name, it's up to you. Now let's add the readme file. I'll select the git ignore Python and license. Let's take any license. I'll take MIT. So once it is done, then let's create the repository. So now let me clone. I'll copy the link address and I'm going to open up my folder, and here let's open up my terminal and I'll clone it. So git clone, paste the link. Done. Now let me go inside cd YouTube Sentiment Insights. That means I'm inside this folder. Now here I'm going to open up my Visual Code Studio. Okay, so now in the next video we'll try to create our first component called data ingestion. So guys, as you can see, I have already prepared like all the files. So let me show you guys. So this is my structure. Okay, that's how I prepared my structure. So in the notebook folder, I kept all of the notebook as well as the pre-processed data. I think previously I showed you. So everything we did in the Google Colab. So I downloaded it from the Google Colab and I kept it here. Okay, just for your reference. Then I created a data folder. Okay, inside data, actually whatever, let's say, artifact will be generated, everything will try to, let's say, save here. Let's say I'm doing the data ingestion. So after ingesting the data, this data will save in the data folder. Okay, then pre-processing. Okay, so these are the things we'll try to save in the data folder. Then in the SRC, actually, I have two folder called data as well as the model. Inside data, I have kept data ingestion.py and data preprocessing.py. And again, I'm telling you guys, there is no fixed actually template. Okay, you have to use. So if you want, you can create any other template as well. Okay, so template is just a like way of organizing your code. If you know better approach, you can follow that one. Okay, so for this implementation, I'm going to follow this particular template approach. Okay, maybe in my previous implementation I used a different one, but in this project I'll be using this particular approach. Fine. So here I kept data ingestion and data pre-processing. So first of all, let me show you the data ingestion part, how we'll be ingesting the data. Then I will also show you the pre-processing as well as the model building, evaluation, and registrar model. Okay, everything we'll try to do. And here I kept one constructor file because this SRC would be considered as my local package. Okay, then I kept the dvc.yaml file. So inside that we'll be writing all the dvc related command, okay, to track my pipeline. Then params.yaml, so inside params actually we'll be keeping all the parameter, like best parameter, I think remember what would be the train test size. Then for the model, actually we selected some best parameter, right, after doing all the experiment on the MLflow. So I think you remember we got actually TF-IDF with diagram. So this is the like parameter, then max feature 1000, then learning rate, okay, max depth, and n estimator, okay, for the light GBM model. Fine. And here is the requirement. So let me delete, these are the things, this is not required. So this is the original requirements. Okay, so here you have to set up, these are the package to execute your project. And here I already kept all the guideline, like how you have to create one environment, then you have to activate the environment, then you have to install the requirements and some DVC command as well as the AWS configuration. Okay, everything I have mentioned here. And there is a setup.py file. So this setup.py file will try to set up this SRC as your local package, and this command I have mentioned in the requirement.txt file. Okay, hyphen space dot. So first of all, let me set up my environment. So I have already created my environment. So what I will do, guys, I will try to activate my environment. If you don't have the environment, first of all try to create, then try to activate. So for me it is already have. Now you have to install the requirement. To install the requirement, guys, just try to execute this command. So for me requirement is already satisfied, but for you it will take some time. Okay, it's done. So once you install, you will see this .eginfo file. That means your SRC has been installed as your local package successfully. Fine. Then guys, the next thing, you have to initialize your DVC, because we'll be tracking our pipeline with the help of DVC. So this is the command, and make sure you have the git initialize. So as we have already created the like GitHub repo and we cloned, so .git is present inside my folder. Let me show you. So the .git is present. Okay, so I'm going to execute the DVC init command. So it will initialize the DVC here. So let me clear and let's initialize the DVC. See, it has initialized and .dvc folder has created. Okay, now let me explain the data ingestion how I have created. Now open up the SRC. Inside that you have one data folder. Okay, now this is the data ingestion.py. And again, guys, the same code, only I have just written in a modular way. So I'm importing all the necessary library, and this is the logger part. That means it will create a log file. Inside that it will save all the log. I think you know what is log in Python, right? Then here I've created a function called load parameters. So this will load this particular parameters. That means in the parameter I have set my what is the test split size. Okay, whenever I'm doing the test split operation, as well as some model parameter. So for data ingestion, I'll be using the data ingestion parameter. Okay, that's why I'm using this particular function to load the parameter. Okay, YAML file. Then load data. So this will load the data from the URL itself. The URL you have in the GitHub, I think you remember. Then I'm doing some basic pre-processing step. That means here you are removing the missing value, removing the duplicates. The same thing we did in our notebook experiment. I think you remember, guys. Okay, same thing I have written inside a function itself. Then once data is pre-processed and it is, let's say, ingested, I'm saving the data as a CSV file inside my data folder. So here after doing the test split, I'm saving that train data as a train.csv and test data as a test.csv. Okay, now here is the main function. So this function will execute, it will load the parameter, and it will only load the data ingestion, okay, parameter, this particular parameter test size. Then after that, this is the load data function I'm calling, and this is the URL I'm providing. Then I'm processing the data. Okay, I'm calling this processing function, I think remember. So see, just try to open the code and try to just hover. Okay, we'll automatically get which function actually I'm calling which time. Then I'm doing the test split, then I'm saving the data in my directory. And if any exception is occurring, I'm raising the exception. Okay, then I'm calling the main function. Okay, so it is done. Now let's try to test whether it's working or not. But before that, you have to write the dvc.yaml file. So let me open up the dvc.yaml file, and here is this traces. Okay, and I already covered like how to write the dvc.yaml file in my MLOps session. Okay, please try to check that. So here you have to create this traces. The first traces is my data ingestion, and this is the command python src data ingestion.py. This file it will be executed, and dependency should be this file itself. Okay, because if this file is not there, then which file it will execute? Then parameter I need data ingestion dot test size, okay, this particular parameter, and automatically this params will figure out this particular parameters, okay, params. That's why I've written like that, data ingestion dot test. That means it will first of all get the key name, then again inside a key name, okay. That's why you can see this particular command here. Where is that? Yeah, command. Then output directory, that means after ingesting the data, it will save the data inside data folder, okay. It will create a raw folder, inside that it will ingest the data. Now let me show you, like I'll execute and let me show you whether it is able to ingest the data or not. So let me save, then I will open up my terminal, and here is the command I already mentioned in the readme file. So DVC repro command you have to execute. So see, it is running the stage. Now see, it is loading the parameter. After some times you'll see that it will ingest the data, it will save inside data folder. So let's wait guys, once the execution is complete I'll come back. So guys, you can see execution is done. Now if I open my data folder, you can see one folder has created raw, okay, and inside that it has ingested the data. So this is my train, and inside that you have clean comment and category, okay, and this is my test, the same thing. Got it guys? So that means we are able to successfully ingest the data. Now if you again execute, see, it won't be running because data is already present inside my directory. That's why it's telling data ingestion didn't changes is keeping, okay, this particular part, and your pipeline is up to date. Okay guys, so now in the next video we'll try to create the next component, which is nothing but data preprocessing. So guys, in our previous video we have seen how to ingest the data, and we executed our DVC pipeline, and some DVC actually a file has also created. Actually you can see dvc.log. So inside the log file actually to track all the, let's say, metadata, okay, of your execution. And you can see guys, it has executed successfully. That means I got my data. Now I will write my next component, which is nothing but my data preprocessing. Fine. Now here I have already prepared the data preprocessing, so let me open it up. So here is the preprocessing code guys, and the same preprocessing we did inside our Jupyter notebook, okay, inside our Colab notebook, the same thing we are performing with the help of NLTK. So here we are importing all the necessary library. This is my login, okay. Then after that, this is the function preprocess comment, okay. Inside that I'm doing all the preprocessing, like stripping lowercase, okay, then removing characters, removing like punctuation, okay, then lemmatizer, everything I'm performing. Then this is the function. So here I'm calling that particular preprocess comment function, and I'm doing the preprocessing of my text. Then after that preprocessing, I'm saving the data into the directory called data folder. So it will create a folder inside data called interim, okay. Inside that it will, then after that I'm saving the preprocessed data, that means my train preprocess and test preprocess. Then here is the main function, okay. Inside that I'm loading my previous ingested data from the raw data folder, you can see, okay, I'm loading it. Then I'm performing the preprocessing step, then I'm saving the data into my directory, okay. So this is the code I have written. Now let me execute and let me show you. So but before that, you have to write the DVC component. So let's open the DVC, and inside that we have to write the DVC command. So I already prepared the command for data preprocessing, right? So here is the data preprocessing step. So after data ingestion, you have to do the data preprocessing. So again, you are executing the data preprocessing file from the folder. Then this is the dependency. So you need these two files from the data ingestion, okay. Then this file itself, and in the output folder it will create interim folder. Inside that it will save the preprocessed data. Now let me execute, okay. So I will open up my folder, and let's run the DVC repro command. So it should work. Let's see. So it will skip the data ingestion because data is already present. Now it will perform the preprocessing step. See. So guys, it's completed. Now if I open the data folder, you can see one folder has created. Now inside that you have the preprocessed data, okay. See, so that's how it is also working fine. Now in the next video we'll try to create our next component, which is nothing but model builder. So guys, in our previous video we have completed the data preprocessing step. Now let's try to do the model builder part. So but before that, let me push the changes inside my GitHub. But here I don't want to push the data folder. So what I will do, in the .gitignore file, I'm going to mention a data folder, okay. So whatever I have inside data folder, I'm not going to push it, okay. So now I think it is fine. Now let me check, everything is fine. So what I will do now, I'll push the code inside my GitHub. So I'll open up my terminal. Let me clear. So git add space dot, and then git commit -name building.py, okay. And here one error you are getting because you have to select the environment, right environment. So here I created the YouTube environment. Let me select. Now see, it is done. Now guys, here I'm importing necessary library. Now this is the logger part, and load parameter, because I also need to load the model parameter, okay. That's why I'm writing this particular function. Then load data, so it will load the pre-processed data from the interim folder, because I have to use the pre-processed data to perform the training. Then I'm applying the TF-IDF to perform the vectorization, okay, with the same configuration I used, okay, here. So that means whatever configuration we got after the experiment, I'm using the same configuration. Then here we are training the light GBM model. As I already told you, light GBM model will be training because this is giving the best accuracy. Okay, so here I'm training the light GBM model, and after that we are saving the model. Then you can see here is the main function, and this particular function will give you the root directory. Okay, your root directory. Now here you can see I'm getting the root directory. Then I'm loading the parameter max features. Okay, in grams. Then learning rate and all from the parameters.yaml. Then I'm loading the data, then applying TF-IDF, building the model, saving the model. That's it. And this is the function calling. I'm doing it here. So now let's try whether it's working or not. So again, I will open up my, okay, but before that you have to add the dvc.yaml. So let me add for the model building. So this is for model building. Now you can see guys, I'm executing the model builder.py from the model folder. Okay, here. Then dependency, your preprocessed data. So to perform the training, you will only need the training preprocessing data. Then you need this particular file itself. Then the parameter. So these are the parameter I'm using, and output. So it will save two actually pickle file. One is for the model.pickle. Okay, so you can see the save model function. I think I written it here, save model. So it will first of all save the model as well as the TF-IDF pickle. Okay, so both it will try to save. Because if I want to do on top of my test data, so again I have to perform the TF-IDF vectorizer. Okay, and in the machine learning, I think you know that in the training data, whatever like say concept we apply, same thing will also apply in the testing data. So that's why we are saving the object, because I don't want to create that object, okay, from scratch. So that's why it will save the model as well as the vectorizer.pickle in the output directory. Now let me try. So I'll open up my terminal and let's write in the DVC repro command. So let's see, it should work. So see, directly it will start from model building. Now see, it is training the model. So completed. Now if I show you, so it has already saved the model. You can see light GBM model.pickle and TF-IDF vectorizer.pickle. Okay, so everything is working fine. So now in the next video, we'll try to do the model evaluation and we'll try to log the evaluation in the MLflow. Okay, so let's try to see how it can be done. So guys, now the next step, we'll try to develop the model evaluation. So we already trained the model. But in the model evaluation, what we'll do, whatever metrics will generate, okay, whatever parameter we are using currently, everything will try to track in the MLflow as well. Fine. So for these guys, what you need to run your MLflow server. Okay, I think I already showed you how to like set up the MLflow on the EC2 instance. So I think you remember previously we launched one server, but actually I again deleted, again I relaunched the server. Now you can see it is running, and this is my MLflow. Okay, it is up and running. Now what you have to do before starting actually development, first of all, you have to configure the like AWS credential inside your local machine. Okay? Because here it has to, let's say, access the S3 bucket to keep all the artifact, right? For this, you need to do the authentication. So for this, you need one tool called AWS CLI. So AWS CLI, okay? You have to just write AWS CLI download. So you will see this website, first website, just try to open it up. And based on your operating system, you can download. See, for Linux, Mac OS, okay, all the commands they have already mentioned. Okay, you can follow. And I'm using Windows machine. So Windows has one file called MSI file. Okay, just try to download the MSI file. See, it is downloading one MSI file. So after downloading it, what you have to do, you have to double click and do next and try to install. Okay, the way you install any kinds of software. For me, I already have it. Okay, that's why I'm not going to install it again. So once you have installed this AWS CLI inside your machine, then just try to open up your terminal. Okay, anything you can open, like Anaconda prompt, command prompt, okay, or git bash, anything you can open. And here you have to just execute one command called AWS configure. Okay, I think you remember we also executed the same command before whenever we set up the MLflow on the AWS server. Okay, AWS configure. Sorry, it should be AWS configure. Okay, so see, if you are getting this kinds of window, that means it is done. Okay, successfully you have set up. Now it is asking for this access key ID. So I think remember we have one CSV file for the access key ID. I'll copy the access key and here I'll try to paste. Then I will give the secret access key. This is my secret access key. Then I will try to paste, and this is my region. So region is US East 1. Okay. Now output format, there is nothing. Press enter. Okay. Now it's done. Now we can easily access our like AWS account. Fine. So I already prepared the model evaluation.py. Let me open it up. So this is the code, guys. And again, the same code you can see. I'm importing all the necessary library like MLflow, sklearn and all. Then this is my logger. Load data. First of all, I have to load the data. If I want to perform the model evaluation, what data I need to load, guys? I need to load the pre-processed test data. Okay. Then load model. Which model? The model actually have trained right now, as well as the vectorizer. See, load model and load vectorizer, both function I have written. Then load parameter as well. Then model evaluation, here we are doing. So here we are loading the model where actually you can see giving the test data, and this will give you the prediction, and we are calculating all the classification report as well as the confusion metrics. Okay, then we are returning it. Then log confusion metrics to the MLflow. So here we are logging the confusion metrics to the MLflow. You can see first of all we are saving the plot, and this plot actually we are logging to the MLflow server as an artifact. Then save model information. Then what we are doing, guys, we are also saving the model information. Okay, why model information? Because I need to do the model registration as well. Okay, so every time what it will generate the run ID. I think you remember in MLflow, in the S3 bucket, it will generate the run ID. In the run ID, it will save all the artifact. Okay, I have to select save the run ID as well as the model path there. Okay, so I'm saving as a JSON file. So this file actually I need whenever we'll do the model register operation. So we'll load the file, and whatever model actually I will get, whatever run ID I will get, I will, let's say, register the model in the MLflow. Okay, that means this function will help me to get the recent model, okay, which we have trained recently. This model information, the model you want to register in the model hub. Okay, then here is the main function, and here you have to give the URI. So let me get my URI. So I think remember, so till here you can copy your URI, and let me set it here. So this is my URI. Okay, so inside the URI it will track all the experiment, and this is my experiment name, and with MLflow.start run, and you can see I'm actually loading my root directory params, then model, okay, vectorizer, test data, then applying the vectorizer. Okay, then you can see I'm logging the model, okay, after calculating all the accuracy and all. Then you can see, then here you can see I'm getting the model information. So here I'm using MLflow.get artifact URI, so it will give the URI, and from there I'm extracting the model path. Okay, then I'm logging the, then I'm also logging the vectorizer, okay, pickle in my artifact, okay, like MLflow artifact. Then these are my like classification metrics, precision recall and all. So these are the classification metrics. I'm also doing the login operation. Then I'm setting some tag. Then this is the main function I'm calling. Now let's try to see whether it's working or not. For this I'm going to add the dvc.yaml. So this is the model evaluation dvc.yaml, and again just go through the code, you will be able to understand, okay, what I have written here. So this is my model evaluation. So it will run the evaluation.py on the model. Then these are the dependency I need. Okay, then it will generate one output, experiment.json, okay, info.json. Let's execute. Now I'll open up my terminal and let's write dvc repro. I think everything is fine. Let me again verify. So everything is fine. Now we can execute. Let's see. Now see, model evaluation is running. So guys, as you can see, my execution is completed and it has successfully tracked all the experiment, and even you can see the metrics it has also generated in a png file. Now what I will show you, see, once now guys, you can see this JSON is also created. Now let me open it up. See, this is your run ID, and this is the model path it has saved in this 3 bucket. Okay, see, this model is available in this 3 bucket in this location. I'll show you. So this model we have to register. Okay, so let me go inside my MLflow. Now if I refresh here, see, it has created DVC pipeline runs, and inside that it has tracked your experiment. Okay, see, this is my final experiment. Okay, I tracked, because in every run I want to track the experiment. Later on, let's say if I want to get to know, okay, what was the parameter I'm using, so I can easily, okay, get from here. If I go to my bucket and if I click here, so this is my experiment ID. Inside that, this is my run ID, FAB. Let me verify. So this experiment FAB, this is the run ID, and inside this particular ID I have my models. Let me open it up, artifact and light GPM. Okay, so this is the model. So guys, you can see the here we have the model. So now let's get back. Okay, that means we are able to successfully perform the evaluation, and all the evaluation metrics we have saved in the MLflow server. Okay, you can see all the metrics we have saved in the MLflow server. Okay, now what we'll do in the next video, we'll try to register the model. That means the recent model we have trained now. So this recent model will try to do the registration. That means we'll register the model in the MLflow, okay, server, and from there we'll create an API and we'll try to get the model. Okay, whenever we'll write the Chrome plugin, we'll try to connect with our Flask server. Okay, so yes guys, this is all about. Let's see how we can perform the model registration. Guys, now we'll do the model register. Okay, so previously we trained the model and we performed the model evaluation, and I already saved the run ID as well as the model path. Now we'll try to actually register this model. So how we'll get the model, because we have the URL now, so it is available in this 3 buckets. So it will load the model from there and it will do the register operation. So how to do it? For this I've written another component, model register. So here is the code, guys. So first of all, you have to set the tracking URI. So let's get the tracking URI. This is my tracking URI and I will update it here. So here we are doing the login operation, then we are loading the model. And guys, here you can see one function I have written called load model info. That means it will load this JSON file. Okay, it will load the JSON file, and from there it will get the run ID as well as the model path. So you can see it will load that JSON file and it will return the model information. Fine. Then I'm registering the model here. So we are getting the model URI. Then here we are doing the model register operation, MLflow.register model. Okay. Then here you can see I'm setting some more parameter. Then after that, you can see I'm setting this model is in a staging area. Then I'm doing actually logger. Then here is the main function. So here you can see. So here you can see I'm first of all giving the location of the JSON file. Then I'm loading the model information. Then I'm giving the model name. Whenever it will do the register operation, it will take one model name. So this is the name I'm giving, YT Chrome plugin model. Then I'm registering the model. Then here is the main function I'm calling. So now let's try to see. But before that, here you have to write the dvc.yaml. So let me write. So here you can see model registration. So this is the command. So it will run this register model. Okay, .py. And here's the dependency. So it will take this JSON as well as this file itself. Okay, and it will not generate anything. That's why I haven't written an output. Now let me execute and let me show you. So let me clear and let's do the DVC inflow command. So guys, as you can see, execution is completed. Now if I go to the MLflow, if I refresh, now if I go to the model section, let's close it. I can see my model has been registered successfully, and this is the version 1. Okay, now inside that you can see, okay, this is the version 1, and this is in staging area. Now from here we can get the model. Okay, we'll write some more script to get the model from here, and we'll create an API on top of it. Okay, so everything is working fine. Now what we'll do, guys, we'll be implementing our Chrome plugin, okay, from the next video onward, and we'll try to create the API. So guys, so far we have completed the entire pipeline. That means everything is working. So we have done till model registration. Now our model is available on the MLflow. Okay, registered. Now what we'll do, guys, let me show you. See, here our plan is to create a Chrome plugin. Okay, so what I told you, this Chrome plugin will let's say this is my Chrome plugin. So let's say this is my YouTube. Okay, this is my YouTube, and here you have the comment, let's say like that. So this Chrome plugin will try to fetch all the comments. Okay, and it will get all the comments. Then we'll create a backend server. Okay, so this is my front-end server, and this should be my backend server. Okay, so here we'll try to create a Flask API, and this will connect the model. This will connect the model. The model is available on the your model registry. Okay, so what will happen? Whatever, let's say, comments your front-end will fetch. That means your Chrome plugin will fetch. It will send to the Flask API. Okay, these are the data. These are the comments. And Flask API will actually get the model, and it will do the prediction, and again this will give the result to the Chrome plugin, and Chrome plugin will try to visualize, okay, on the YouTube page. Okay, so this is the plan actually. So first of all, what I will do, we'll try to create this Flask API, okay, Flask API part, and we'll create an API and we'll try to test this API with the help of Postman. And if our API is working fine, then we'll try to develop our Chrome plugin. Okay, then we'll try to connect each other. Okay, and again, guys, for Chrome plugin you need JavaScript. Okay, JavaScript, then you need HTML and CSS. So I know that many people actually don't know about that. No need to worry, even I'm not actually good at that. So what I did, actually I used ChatGPT a lot to generate actually these are the codes, okay, for the Chrome plugin. So no need to worry. So there would be a separate team for that. They will create the front end part for you, but as a MLOps engineer, as a machine learning engineer, you have to know about the backend part. Okay, this thing we'll try to learn. So let's open up my code base. So this is my code base. So here what we'll do, guys, we'll try to create the Flask actually API part. So for this, let's create a separate folder. I'm going to name it as Flask API. Inside that, let's create a file. I'm going to name it as main.py. Then inside that, I'm going to import some necessary library. So let me import all the necessary library I need. Okay, so these are the library actually I need, guys. And now here you can see I'm using Flask, and let's initialize the Flask. Okay, so that's how actually you have to initialize the Flask. Then after that, you need a preprocess function. I think you know why preprocess function is required, because we have to also apply this preprocess function on top of the raw comments. That means my Chrome plugin will fetch the comments and it will send to the backend, and it will first of all process the comments. That means it will apply the lowercase stripping, then stop word remover, okay, lemmatization. Then actually we'll be able to actually use this particular comment. But before that, we also need to do some other pre-processing. I think remember we have to also apply the vectorization technique. The TF-IDF vectorizer we have saved, right? So this object TF-IDF vectorizer.pkl, we have to also apply this because this is a raw comments. We have to convert it to the number. Okay, so that's why we saved this particular object. Okay, now to load this actually tokenizer as well as the model from the registry hub, you can use this particular code snippet. Let me show you. So this is the code, guys. So this particular function will let me just make the comment here. So this will load the vectorizer. Okay, so this particular function will load the model from the registry hub, and it will load the vectorizer from the directory itself. Okay, because this vectorizer is available in the directory, and our model is present inside my MLflow server, I think remember. So that's why you have to give the MLflow URI. So guys, I think you remember we launched a EC2 instance. Okay, MLflow EC2 instance, and this is the URI. Just try to set. So for me, actually, I stop the recording, then I terminate all the instance because I was in leave actually 2 days. That's why I terminated all the instance. Then today actually I have again started recording. So that's why actually currently my MLflow server is not available. So what I will do, instead of using this function, I will use this function. That means I will load my local model. Okay, instead of loading from the registry hub, I load the model from my local directory. Okay, that means here you can see I have the model, like GBM model.pkl. So this model I will try to load. But for you guys, if you want to load your like registry model, that means the model you have registered in the MLflow, okay, you can use this code. So here you have to pass the model name and model versions. I think remember in the registry hub we have given the model name, like we have given like YT sentiment model, right? Then model version, it was version 1, so you can specify the name. And here you can give the vectorizer path. Okay, but that means this particular vectorizer path. So it will first of all make a client of MLflow, then it will create the model URI, it will fetch the model, okay, and it will return the model, as well as it will also load the vectorizer, it will also return it. Okay, so for me, I'm not going to use this function as of now because I already terminated all of my instance. Okay, so I will comment this function. So I'll load my local model, okay, as of now. So this is the function I've created, so it will load the model with the help of pkl. Okay, so both vectorizer as well as my model actually I'm loading here. So for first function, that means this function, you have to use this line of code. Okay, so let me uncomment and let me show you. You have to use this line of code. Let me make a comment. So here you are calling this function, and inside that you are giving the model. So what was your model name, guys? So I think you remember in the registry we given the name of the model. So here it was the name, Mighty Chrome plugin model. I'll copy the name, and here you can pass the model name. Okay, so this will load that particular model, version 1 model, and here I'm giving my TF-IDF vectorizer path, because you can see this is available in my root directory. That's why I'm given /. Okay, so this is for this function. Now let me comment as of now, and the second one, this one. So this this particular code is for this function. Okay, so here I'm loading I'm calling the load model, and I'm passing my model.pkl path as well as my vectorizer.pkl path. It will load the model as well as the vectorizer. Okay, fine. Then I will initialize my first route of my Flask. So this is my first route, you can see. So this is the default route. So if you hit the route, it will tell you welcome to the Flask API, just to test, okay, if it is working or not. Then here I'm going to create my predict route. So this predict route will first of all try to test with our postman. I think in the postman with the help of postman you can test your API. So this is the /predict route. So this particular function will take the comments from the, let's say, postman. That means we'll try to pass the comments in a JSON format, okay, and it will accept, and then I'm going to store inside this variable. As of now, let me comment this 2 line. It's not required. Then I'm checking if it is not comments, then no comments provided. Okay, I'll raise one exception. Otherwise, I will first of all pre-process that comment, okay, with the help of this pre-process function. Then once pre-processing is done, then I'll also perform the vectorization. Then I'll convert to 2 array, because I have to convert to the dense actually array. Then after that, we'll do the prediction of the model. Okay, then this particular prediction here we'll try to return like that. Let's say comment sentiment. Okay, that's how we'll try to return. So now let's try to see how it will work. So let me initialize my Flask server. So this is the code. So here I'm using localhost and port number 5000. Actually, it will execute. So I will open up my terminal. So Python, it is available in the Flask API main.py. Now guys, you can see your Flask application is running. If you want to test, just go to the browser and search for localhost port number 5000. You can see welcome to Flask API. This is showing, okay, and you can see response you are getting 200. Now let's open up our postman. I already installed postman, guys. If you don't have the postman, simply just write postman download on the Google, download postman. So here is the link, guys. So if you're using Windows, so just download 64-bit, okay. And if you're using any other operating system, you can see the guidance. So I already have the Postman. So what I will do, I'll open it up. I'll open up my Postman. So here what you have to do, guys, let's delete my this one, okay. I'll create a new one. Create account to save discard, okay. Yeah, I'll create a new one. Just click on the plus icon, then here it should be a post request, okay, because you can see in the API you have mentioned it should be a post request, okay. That's why. Then here you have to give the URL. Now I think, guys, you remember that this is the URL your application is running. Copy, and here you have to paste, and it will hit which route, guys? It will hit the predict route. So let me show you. It will hit the predict route, okay. So here I have to give the /predict. Here I'll give /predict. Then yeah, I think it is done. Then I will select the body. Then you have to select the raw text, okay, and you have to select the JSON here. Then here you have to pass your comments. So I already prepared one comment, so let me pass. So let's say this is the comment I prepared, guys. You can see comments. So here I have 2 comments in the list. This video is awesome, I loved a lot, and very bad explanation, very poor, okay. So these 2 comments I have. Now let's try to see the sentiment. Now my application is already running, guys. Make sure your application is running. Now just try to send the request, okay, and it will give you the response. So let's see. So everything is fine, I think. Now yeah, I'll send the request. So guys, if I send the request, you will see that so here I got the sentiment. So this video is good. It is telling it's a sentiment is equal to 1. That means a positive sentiment. And the next one, a very bad explanation, poor video, it's a negative, okay. You can see it's a negative sentiment. Now you can also pass any other one. Let's say I'll pass your video is good, nice presentation, okay, presentation. Again, if I send, now see, again it's a positive sentiment, okay. And if you're using any political, actually, let's say comments, so it will work better, because the data actually we used, it's a political data, okay. That means my API is working fine, okay. My API is working fine. Now we are ready to create our Chrome plugin. Now what I will do, guys, in the next video I will try to implement our Chrome plugins, and I've already prepared the Chrome plugins, guys. I'm not going to develop from scratch. I will share the code with you. It's a JavaScript and this HTML CSS code, okay. So no need to understand, there will be other team, okay, for this. I use the ChatGPT to generate the code, okay. In the next video we'll try to implement our Chrome plugin, and we'll try to run our application, okay, on the like YouTube browser, okay. So let's connect in the next video, guys. So guys, I already prepared this API and everything is working fine. Now in this video we'll try to show you how we can integrate the Chrome plugin. So here is the folder, guys, I have added inside your project, YT Chrome plugin frontend. So inside that, actually I have one JSON file, then I have one HTML file, and I have one JavaScript file, okay. Now let me open up. So let me show you how they look like. So if I go to this folder, so see, if you want to build a Chrome plugin, if you have idea about the Chrome plugin, how to implement, so you have you need first of all one JSON file called manifest.json, okay. Inside that you have to mention the name of the Chrome plugin, the version, the description, okay, the action. That means it will pop up the HTML window. So it will open up this HTML window on the browser, okay, and there actually it will show all the, let's say, analysis. And here you have to provide these are the permission. Then you need another file called HTML. So inside HTML, actually I have written all the HTML and CSS code for my web page, okay. That means it will open up actually front end page. There it will show my analysis. So for this I have created this HTML file. Then I have one popup.js, and in that file actually I have written all the JavaScript code, okay, with the help of, that means this code will extract the comments from where, from this YouTube, okay. And how it will fetch, it needs one API key, guys. You can see this is the API key. So this is the Google Cloud API key, okay. So how you can generate, so for this you need Google Cloud account, guys. Just search for GCP console, okay, guys, search for GCP console, go inside that, okay. And here just try to go to the console and try to create one account, okay. If you don't have the account, just try to create, and it's not a free, you have to add your card, okay. Then after that you can search for YouTube API in the search engine, okay. In the search bar you can search for YouTube API, so you will get the YouTube API, okay. Then you have to generate one API key. I'll share one actually video in the description, okay. So here what I will do, in the readme file I will share one video link, so it would be available in the resources section. So there I will add one video. So with the help of that video, actually you can generate this API key, okay. So what is that? So this API key you can generate, okay, from the Google Cloud. Now you can ask me why this Google Cloud API, okay, because this API is pretty good. It will give you the real-time information about the YouTube, like how many comments you have here, all the comments it will try to extract, okay. So this API key will help you to extract the comments from the YouTube. Then my application is running on my localhost 5000, okay. And these are some like JavaScript code, guys. Inside that I have mentioned like it will extract the comments and all. Then after that actually it will perform the it will send to the front end will pass that prediction here, and it will show in the web page, okay. So here I have written all the logic. and it will also like create the graphs and all. Okay, everything I have mentioned here. Now let me execute and let me show you how they look like actually. So for this actually you have to first of all create this Chrome plugin. So to create the Chrome plugin, guys, just go to your browser. Okay, and here I have given one link. You can see in your readme file, just try to copy this link. So Chrome clone/extension. So you have to search for here. Okay, and make sure you activate your developer mode. Okay, so I already activated my developer mode. Now here you have to upload the folder. Okay, the folder actually I have shared with you, this Chrome plugin folder, this Chrome plugin, okay, front end folder. So it will automatically create the Chrome plugin for you. So load and back. So inside that I have my, let me go inside my folder. So this is my folder, guys, Chrome plugin front end. I'll select the folder. Now see guys, it has added. Okay, now what I will do, I will let's say if I open any other, let's say tab, let's say I've opened Google Cloud Console. Now see, if I try to open my plugin, so it will tell it's not a valid actually URL. Okay, because it's not a YouTube URL. Now let's open up my YouTube URL and let me show you how it will fetch the comments. So I'll open up my channel. So here I have some, let's say, video. I will open the generative AI mastery course. Now here let's activate my Chrome plugin and let's try to see whether it's working or not. I will click here. Now guys, you can see it is fetching the comments. So it found the comments, and guys, I'm not picking all the comments here. Okay, I'm only picking top actually most top actually comments. Okay, but here you can see it is throwing one error fetching sentiment prediction, because here still you have to add some more function in the app.py, your main.py. Okay, that means in your API. So let's open the main.py. So let me add all the function one by one. So the first function you need this particular function, this particular route. So guys, you need this route actually predict with timestamp. So this will actually predict and it will also show you the timestamp and all. Okay, so here is the route and I already prepared, and this is the same thing. Okay, here we are loading the comments, we are pre-processing it, and we are actually doing the prediction and we are showcasing. Okay, then the next thing you need generate chart. So if you want to see the chart and all, like I also told you, now we'll also plot the chart and all. So for this route we'll be using, so this route will generate the charts. Okay, I will show you the practical demo, then we will understand. Okay, then I will also show the word cloud. That means word cloud will give you the entire comments distribution, okay, in a bigger picture. This is the word cloud route I have created. So it will actually create the word cloud. So here I already imported the word cloud. Okay, then after that I need another route called generate trends graph. Okay, so it will also generate the trending graph. Okay, so this is the another route. Yeah, now let me save. So application is still running. You can see it has restarted. Now I will go to my browser and let's refresh. It has the power. Now again I will open up my Chrome plugin. Now see, it is fetching the comments. Then after that, guys, this is the summary I got, guys. You can see. So comment analysis, total comments, actually it has extracted 117. So here I already told you I'm extracting most actually top comments. Okay, not all the comments. If you want, you can also extract all the comments. Now this is the unique comments. This is the average comment length, and this is the average sentiment score. You can see. Okay, now the sentiment analysis result, you can see how much positive percentage you got. 31% positive. Okay, then negative you got 5.1%, and neutral you got 63.2%. okay, so it has generated one amazing pie graph because of this particular route. Okay, I think you remember we created this function graph. Okay, generate charts, that's why. Now let me open it again. Now it has also given you the trending graph. You can see based on the timestamp. You can see the word cloud. So thank you, sir. Okay, so these are the words has been used a lot in my video. Now here are top 25 comments actually with the sentiments. You can see how to get a certified course. It's a neutral sentiment, then again it's a neutral sentiment, again if you read it's a neutral one, and that's how you have all the sentiment with all the top 5 comments. Okay, you can see. So it's, guys, it's amazing, right? So you can see there is another video comments, a great video, clear explanation. That means it's the positive sentiment. Okay, so yes guys, this is the application we have developed with the help of machine learning, and we use the entire MLOps technique here. Okay, I hope you like this, and let me know, guys, how about the project. Now you don't need to open up your YouTube comments and you don't need to go through all the comments. Now just try to open up your plugin. It will automatically fetch all the comments and it will show you in the entire summary, okay, of that. So yes, this is what actually we have implemented, and the entire code I'll share with you. Just go through the code, definitely will be able to understand, and no need to worry about the front end part, because for front end actually there would be other team, okay, for you. Now what you can do, I can actually push my changes inside my GitHub. So update it, let's push. Okay, it's done. One thing, guys, I forget to tell you. Let's say if you're changing anything inside this JavaScript or HTML or this manifest.json, that means in the Chrome plugin code. So what you have to do, every time you don't need to upload it here. So instead of that, here is the refresh button. Okay, So just try to reload. So it will reload actually entire updated code, and again it will update in the you can say Chrome plugin itself. So every time you don't need to upload it. Okay, so just try to, let's say, change the name and all. Okay, if you want, you can also change the name. Let's say in the HTML file, if you want to give any other title, you can give. Okay, based on that you can also change the color and all, and you can reload and it will automatically reflect. And if you want to remove it, there is a remove button. So if you click it, so it will remove the Chrome plugin from your Chrome itself. Okay, so guys, we have completed the development. Now it is ready for the deployment, guys. And deployment wise, I have already taken lots of session on that, like how to create the CI/CD pipeline, okay, how to add the Docker, how to do the deployment of the AWS cloud, okay, with the help of CI/CD. So each and everything I already created. So what I will do, I will add those deployment video. By saying that, definitely will be able to deploy this project. Okay, but the only thing you need to change here, let me show you. So if I open the popup.js, see, whenever you are deploying the project, so make sure you are giving the deployment URL here. That means in the EC2 instance, whenever you will try to deploy, so the URL will try to load. Okay, so this URL you have to add here. Okay, because it is now running on my local machine. That means this project is now running on my local machine. That's why here I have given the local URL. But whenever you are deploying your project on the cloud, so you have to give the cloud URL here. Okay, otherwise everything will remain same and you can deploy this project as it is. Okay, so I'll add the deployment video. By seeing the video, first try to deploy. And if you face any issue, you can let me know. Definitely I'll try to help you with that. So yes guys, this is all of our development. I hope you liked it. So thank you so much for watching this video, and I will see you next time. Okay, so to create the Docker file, just try to first of all create a file here. So I'll name it as Docker file. So make sure you are giving the similar name, otherwise it won't be working. D should be capital. And I'll get the Docker icon here. Okay, once you have created this file, and there won't be any kinds of extension. Now inside that you have to mention the Docker command. So these are the command you have to mention. So first of all, here I'm taking one Python image actually, because I think you remember we are using Python 3.8, right, environment. So that's why I'm taking one Python 3.8 slim buster image. If you have basics knowledge about Docker, it would be better. Otherwise, I know that you will be getting confused, but as of now, just try to remember this is the Docker command actually I need if I want to Dockerize the entire source code. Okay, that means it will Dockerize the entire source code, and this Docker image actually will be using for the deployment. Okay, this is the idea. Now I'm creating a directory called app. Inside that I'm copying all of my source code and I'm doing the requirement installation, and then I'm executing my app.py. Okay, that's it. And it would be running inside Linux environment. That's why you have to give the Python 3 command. Okay, so this is the simple Docker file. Now let's start the deployment. For this, definitely you should have AWS account. If you don't have the account, just try to create one account. Okay guys, so now we'll start the deployment, and here you can see I have already added the deployment steps, like what are the things we're gonna perform. You can see first of all I have to log into the AWS console, create the IAM user. Okay, then this is the deployment actually description. Like first of all, we'll be building the Docker image of our entire source code. Then we'll be pushing this image to the ECR. So here we'll be using some services from the AWS. One services we'll be using called ECR. That means Elastic Container Registry. So here you can push any kinds of Docker image. So this is the alternative of the Docker Hub. I think you know Docker Hub. Okay, there you can also store the Docker image. Then we'll be launching the EC2 machine. EC2 is a virtual machine, virtual computer. Then we'll be pulling this image to the EC2 machine. Then we'll be running that image to the EC2 machine. Okay, then we'll be doing some port mapping. Then we'll be able to access the application. And this is the policy I have to give. Okay, whenever we'll be creating the IAM user. So you can see all these steps actually I have written down here. So we'll be following these are the step one by one. See guys, before starting the deployment, you need one very important you can say file called cicd.yaml. And this file you have to create inside a folder. So let me create the folder first of all. So the folder name should be .github. Okay, .github. Inside this folder, you have to create another folder called workflows. Okay, now inside workflows, you will be creating one file called cicd.yaml. So this YAML file will help us to do the deployment. Okay, it will execute all the automated command, because here we'll be using GitHub action. Okay, as our CI/CD tool. And for this, we need this file actually. And the folder structure should be like that. First of all, .github, inside that workflows, inside that cicd.yaml. And these are the command you have to mention here. And now you can ask me where I got this command. Just simply search on internet how to do the CI/CD deployment with GitHub action AWS. You will get this actually cicd.yaml file, okay, from the GitHub site, and you can copy paste the same thing and you can do some modification. So what I did some modification here, and rest of the things I keep it same. So it will perform the continuous integration, then continuous delivery, as well as the continuous deployment. Okay, I'll tell you what will happen whenever we'll be doing the deployment. As of now, just try to remember this is the thing you have to do. Now you have to mention the port here. I think you remember we are running our application in port number 8080. That's why we have given port number 8080. If you are using any other port, you have to change the port number here. Okay, yes. Now, see, before starting the deployment, guys, first of all, I will tell you what is CI/CD deployment exactly. For this, I already recorded one video previously. I'll add this video part in this video. This will give you the entire understanding what is CI/CD deployment and why we need it exactly. Okay. Then after that, we'll be starting the deployment. So guys, as I already told you, here we'll be doing something called CI/CD deployment, right? And I already told you what is CI/CD full form. It's continuous integration, continuous delivery or deployment, right? So inside continuous integration, continuous delivery, what happens? Let's say you are the developer. Okay, let's say you are the developer. So what is your task? Your task is to develop a project in the development, let's say, environment. So development environment means like your local system. Let's say you are using your laptop or computer. That's a local computer. Okay, local computer. Fine. Then what we are doing, I think you remember, we are committing this code to the GitHub, right? We are doing the code management. I think you remember. That means whenever I was adding some new feature, I was pushing this code to the GitHub. Yes or no? Okay, with the help of Git client, we are pushing the code in the GitHub server. Now what happens actually, let's say after deployment. So this is called actually development server, or I can write this actually development environment. Okay, development environment. So after implementing this project, what we have to do, we have to deploy this project, yes or no? Let's say somehow you have deployed this project on the AWS cloud. Let's say this is your AWS cloud. Fine. So let's say you have deployed this project to the AWS cloud manually. You just created a, let's say, instance there. You just took a machine there, a EC2 machine, and you manually deployed this project. Now it will give you some endpoint. Okay, endpoint. So with the help of this endpoint, any of the user can access your application. Now let's say after 4 months or let's say 6 months, you want to add some more features in this, let's say, application. Let's say you are deploying medical chatbot. The medical chatbot we implemented, I think you remember, right? Let's say you want to add some more data, you want to add some more knowledge base, and you want to add some more features in this application. Then what you have to do, you have to again develop this, let's say, features in your code. Then what you will be doing, again you will be deploying this application to the AWS cloud. Now just try to see, whenever you are deploying the project for the second time, let's say this is the first time you have deployed, then you are trying to deploy for the second time, then what you have to do, first of all, you have to stop this application in the AWS. Okay, stop this application, then you will be uploading your updated code. Then this code will reflect to the endpoint, then user will be able to access that. Now let's say in between, whenever you stop this AWS server, let's say your application, let's say it took 3 hours to change the entire source code, that means change the entire features, okay, of your application. So what will happen, 3 hours user won't be able to access your application. So they will come your website and they will see server error. Okay, server error actually they will get. So if user is getting this kinds of experience, so definitely it would be a negative, let's say, effect, okay, on your application. So next time actually they are not going to use your application, yes or no? Let's say if ChatGPT is down for the let's say 3 hours, definitely people will move to the Google Bard or any other software, whatever actually we are having. Okay, so now see, ChatGPT is also updating their, let's say, application day by day. But did you ever observe this server is down? No, you are not seeing this server is down, but still they are able to make the changes in their application. How? Because they are following something called CI/CD approach, continuous integration, continuous delivery. That means this application is keep on running, but in the backend they are pushing their source code, they are pushing their, let's say, new features, and this feature is automatically getting updated. Okay, so this is called actually CI/CD. That means you are not going to deploy this application manually. Instead of that, what you have to do, you have to follow the CI/CD. That means what will happen, let's say you have changed something in your code, you will push the code to the GitHub. Okay, GitHub will automatically, let's say, deploy your code to the AWS cloud. It will automatically push your code to the AWS cloud, and your endpoint would be automatically updated. Okay, automatically updated, so that if user is using your application, okay, they won't be feeling any kinds of, let's say, server down issue. Okay, server down issue actually they won't be feeling. Got it? So this is what actually we have to do. That means we will be creating the entire pipeline, entire, let's say, CI/CD pipeline. So we will be just pushing the code in our GitHub, and GitHub will automatically trigger this action, and my code will update it to the AWS cloud, and AWS will update the endpoint. Okay, now see, the automated process we'll be doing. Now whenever we'll let's say push our code to the GitHub will automatically trigger. How it will trigger? For this you have to use some CI/CD tool. Okay, CI/CD tool, CI/CD automation tool. So here there are different kinds of CI/CD tool. So the first tool you can use something called GitHub Action. Okay, GitHub Action you can use. Then you can use something called Jenkins. Okay, Jenkins. Then you can use something called Circle CI. Circle CI. So these actually 3 famous tools actually we are having in the market right now. So people are using more this GitHub Action because GitHub Action you don't need to set up anything. It is already set up everything in the GitHub. But if you're using Jenkins and Circle CI, you have to set up this server manually. Okay. So here we'll be using GitHub Action because it is already inbuilt with the GitHub. We don't need to set up anything. Going forward, I will also show you how we can, let's say, use Jenkins, Circle CI. These are the services as well. Fine. So yes, guys, this is the complete high level architecture of our deployment. So guys, I think you saw what is CI/CD deployment and why it is required. And now let's start the deployment. But before that, let me give you some high level walkthrough of this file. See, inside continuous integration, I'm not doing anything. I'm just only doing the echo operation. But going forward, if you are running any test cases, you can execute the test cases inside continuous integration. Inside continuous delivery, I'm just authenticating with my AWS account with the help of AWS access key and secret key. I'll tell you how we get it. And after that, what I'm doing, I'm building my Docker image. Okay, with the help of Docker file. It will build the entire Docker image, then it will push this Docker image to the ECR repository. Okay. Then inside continuous deployment, I'm again, you can say, authenticating with my AWS account with the help of this credential. Then I'm pulling my Docker image inside my EC2 machine. Okay. Then I'm executing here. Okay. And then after that, we'll be doing some port mapping and we can access our application. This is the high level walkthrough. Now let's go back to my AWS. So I already have one AWS account, guys. If you have account, please try to log in with your account. And if you don't have account, try to create one account. So the first thing what you have to do, you have to create one IAM user here. So let me create one IAM user. So you can simply search for IAM. That means identity access management. That means you are not going to give all the permission of your AWS account. Okay, because you need some certain services here. So we'll be only giving that particular permission. Okay, that's it. I'll just click on the user and let's create a user here. Now I'll give the user, let's say, ML project. You can give any name. It's up to you. Now let's attach the policy. So here I already added the policy, what policy actually you need in the readme file. So here I need two policy. One is the EC2 container registry full access, that means ECR, and this is the EC2 machine. Okay, so simply search here and just try to tick mark it. Okay, once it is done, just try to remove and again give the second permission. So search here and try to give the permission and simply click on the next. I'll see that two permission I have added. Now I'll create the user. Now so user is created. Now click on the user, go to the security credential, go to the access keys, select command line, and I understand the above recommendation. Click on the next. After that, create the user. And this is your access key and secret key, guys. Okay, now you can download it as a CSV file as well, so that I need later on. Okay, so yes, and don't share this key with anyone, otherwise they will be also able to access your account. Okay, so I'll remove it after the recording. That's why I'm showing you. So it is created. Now you can see this first step we have done. That means we have logged into the AWS credential. That means we have logged in our account. Then after that, we created the IAM user, okay, with the permission we have given. Now the next thing, I have to create the ECR repository. Okay, so to create the ECR repository, search for ECR, Elastic Container Registry, ECR. So this one, and make sure you track your region. Okay, see, I'm working in the Mumbai region. If you're using any other region, you have to give the region ID. Okay, so here I'll be using AP South 1. Got it? So create the repository. So you can give any name. Let's say I'll give ML project. Keep it everything default, no need to change anything. Create the user simply. Okay, and copy this URI and save it somewhere because I need it later on. So let's say I will save it here as of now. Okay, now the next thing, I have to create a EC2 machine. Okay, Ubuntu machine I have to create. So for this, here you can search EC2. That means virtual machine EC2 instance. So simply just click on launch instance, give the name, let's say ML machine. You can give anything, it's up to you. Select the Ubuntu. Then after that, you can select the instance type. Let's at least take 8 GB memory, guys. Okay, 8 GB memory you have to take. So let's take T2 large, and after that, select the key value here. If you don't have a key value, you can also create. Let's create ML project. So this key value here you need. Let's say if you want to access your machine with the help of any third party, let's say tool, let's say Mobile Stream or Putty, that time actually you need it. But here I'm not going to use third party tool. I'm going to directly launch the like AWS CLI. Okay, from there actually we can access our machine. I'll tell you how to do it. Then after that, select these two options, HTTP and HTTP. Select the configuration storage, at least take 30 GB. After that, let's launch the instance. So click on the view instance. Now it should be running. Just refresh here. The status should be running. Now guys, you can see my status is running. That means my machine is running. Now click on the machine ID and click on the connect button and simply connect. Okay, it will open a new window and there you will get one black terminal. And this is your production server. So guys, you can see I got the terminal. Let me zoom a little bit. Now let me clear. Okay, now here you have to set up some of the tools. So here I have already mentioned the command. So these are the command you have to execute. First of all, let's update the machine. Okay, then so need to update the apt-get update. Give the yes permission. Okay, it's completed. Now I'll copy this command. Now we'll be installing Docker, okay, in my machine because Docker is not there by default. So for this, you have to execute the command. Okay, so next command. Now I think the last command we have to execute. So these are the Linux command. Now it's done. Now if you want to test whether Docker is running or not, just write docker --- version. So it will show you the version. Okay, if showing the version, that means Docker is running successfully. Okay. Now the next thing will be configuring this EC2 as our self-hosted runner. That means we'll be connecting our GitHub with our AWS. Okay. That means whatever, let's say, commit will be doing in my GitHub. Okay, it will automatically, let's say, push to my AWS cloud. Okay. For this, what I will do, I will open up my GitHub repo. Make sure you are using your repository, not my repository. Click on the settings. Now here you will see one option called action. Now runner. Now here you will see self-hosted runner. Just try to click here. Select the Linux machine and you have to execute these are the command. Okay, till configure. So let's copy one by one and let me execute here. Okay, so this is the command. Now I'll go to the configure and copy this command and let me execute. Now I'll see that it will connect with my GitHub. Okay, with help of GitHub action. Now see authenticating GitHub. Now it is asking for the name of the runner group. I won't be giving anything. Just press enter. That is asking enter the name of the runner. You have to give self-hosted. Okay, make sure you're giving the same name, otherwise it won't be working. Now it is asking for the label. I skip it. Press enter. Then again I'll press enter. Okay, now press enter. Now see it is done. Now let's connect the GitHub. So for this, let's copy the last command and let me execute. Now see guys, connected to GitHub and listening for the jobs. That means connection is done. Now if I check the connection, just go to the runners, you'll see that it's ideal. That means my GitHub is connected. Okay, it's up and running with my AWS. Now whatever change I will be doing, it will automatically get updated. Okay, but before that I also need some security credential. Okay, with the help of credential it will authenticate with my account. So here I already mentioned, after that you have to add some security. Okay, secrets. So let's add the secret. For this, left hand side you will see secret and variable. Go to the action and repository secret. Okay, create a new repository secret. First of all, give the all the list I have given. So copy this one, AWS access key ID, give the key name, and here you have to give the secret. And where you will get the secret, I think remember we downloaded one, this access key. Okay, whenever we created the IAM user. So let me open it up. So this is my secret. Okay, access key ID. I'll copy. Make sure you're copying before the comma because it's a comma separated, right? So this is my access key ID and after comma this is my secret access key ID. So I'll copy and mention it here. So don't do any mistake, otherwise it won't be working. Okay, try to follow the exact step I'm doing. Now create a new repository secret again. Now I have to add the AWS secret key ID. I'll copy and I'll paste it here, and this is my AWS secret access key ID. Before the comma, let me mention. Now new repository secret. Next one, AWS region. So here I was working in the Mumbai. You can see I'm Mumbai and Mumbai ID is AP South 1. So let's give the name. It should be AP-South-1. Okay, make sure you are giving the same name. And if you're using any other region, you can give the same ID here. So it's done. Now let's give the ECR login URI. Copy. Now what is ECR login URI? I think remember we copied one URI, right? This one. So copy till .com and try to paste it here. And make sure you are giving your one, guys. Okay, not my one. Otherwise, it won't be working. Now the next one I'll be creating ECR repository name. And what is ECR repository name? So here you will get it. So the last one after the /ML project. Done. I think nothing is there. Now let's start the deployment. Okay, so I'll go back to my repo. Now simply I just need to commit my code. So let's commit CI/CD it. Okay, done. Now if I go back to my GitHub and refresh here, you'll see that your action would be running. Okay, there is a yellow mark. Now go to the action and CI/CD is added. It's running. Now see continuous integration is running. Then continuous integration is already done because here I was doing the echo operation. Now continuous delivery is running. Now let me open it up. See, first of all, it will install all the required packages. Then it will authenticate with my AWS. Okay. Then after that, it will build a Docker image and it will push the image to my ECR repository. So this process will take some time. Let's wait. Once it is complete, I'll come back. So guys, as you can see, my delivery is completed. Now, if you go to the ECR, you'll see the image actually it has pushed. So let me show you. If I go to the Elastic Container Registry, see, this is my ECR has been created. Now inside that, this image has been updated. Okay. Now the next stage is running continuous deployment. So what will happen now? It will again authenticate with my AWS cloud. It will pull the image from my ECR and it will run in my EC2 machine. Okay. So guys, as you can see, my continuous deployment is also completed. Now what I will do, I will get back and here you will see one public IP address. Just try to copy and just paste here. And see if I execute, see it won't be working because I have to set my port. Okay, because my application running port number 8080. Okay, so how to set this port? For this, just go to the security and here we will get one option called security groups. Then click on this edit and bound rules. select this custom TCP. I have to add the rules, then I have to select the custom TCP and port number 8080, give the 000 and save the roles. Okay, once it is done, get back to the instance. Now copy the public IP address again and try to paste here and give the port number 8080. Okay, now it should work. See guys, my application is running. Now what you have to do guys, first of all you have to train the model. I think you know. So to train the model, give the /train. Guys, you can see training is successful. Now I will go back. Now I can do the prediction. Let's give the number. You can give any number. I'm giving, so you can give the actual number. I'm giving the dummy value just to test whether it's working or not. Okay, after that I'll click on the predict. Okay, I have to give this number as well. You can see this is the quality of the wine. Okay, that means everything is working fine. Now let me show you how we can destroy all these instances you have created. Let me show you the termination, otherwise it will charge you, okay, if you keep on running this. So for this, first of all, I will stop the instance, select the instance, click on the instance type, instance, and click on the terminate. Okay, terminate means it will delete after some time. So it is shutting down. After some times it would be deleted. Now similar wise, I also need to delete my ECR repository and delete. And one thing, let me tell you, see, whenever your application is running and if you are adding some new feature, okay, next time, so you have to execute this, you have to uncomment this 3 line. Okay, this 3 line, what it will do, it will first of all stop the current running container. Okay, then it will, let's say, launch your new container. Okay, so make sure whenever you are pushing second time, that means the second time if you are pushing, you don't need to do the configuration, it's just a one-time setup. Okay, so it will automatically update your application in the AWS clouds, but before that you have to activate this 3 line. Okay, I hope it is clear. Now let me show you how to delete. Yeah, so it is already deleted. Now I will be also deleting the I'm user ML project. Just try to delete it, give the name, I'll copy, and here let me paste. Okay, see, everything is deleted. So yes guys, that's how actually we can do the CI/CD deployment, and I will see you next time.